Hello students. Today we are going to solve few questions on probability. These questions are very important from the competitive examination point of view and also from the board examination point of view. So let's begin with question number 1. If you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Let's begin with question number 1. Find the probability that vowels may occupy the even place when the letters of the word rough are arranged at random. Here the given word is rough. So that means which has 5 letters, right? So number of letters in the given word are 5. So in which the even places are second place, this is even place, and fourth place, right? Fourth place is even, right? And number of vowels that may occupy even places. There are 2 vowels, O and U, right? These are 2 vowels in the given word. So in how many ways these 2 vowels can be arranged at even places, right? So in one way, so you have to take O and U, and also in another way, you have to take U in second place, O in the fourth place, right? There are 2 ways, right? That means factorial 2, right? So number of ways in which vowels can be placed or vowels can be arranged at even place. Even place is equal to, so you can place these 2 vowels in 2 factorial ways, right? And number of ways in which the remaining letters can be arranged. So remaining letters are R, G and H. These are the remaining letters. So number of ways in which remaining letters can be arranged is equal to, so there are 3 remaining letters R, G and H, right? Therefore it is factorial 3 ways, right? Factorial 3 ways. Remaining letters you can consider R at first, then G, so in the third place, and lastly H. Or you can consider G as first letter, right? R as third letter, H as last. So there are factorial 3 ways, means 3 into 2 into 1 ways, right? Therefore, so total number of ways in which the vowels can be arranged at even place, right? And also the remaining letters. So total number of ways is factorial 2 into factorial 3, right? Factorial 2 into factorial 3 ways. This is total number of ways in which vowels along with remaining letters, right? Along with remaining letters can be arranged is factorial 2 into factorial 3, right? Here consider rough as, so the 5 letters without any restriction. That means the vowels should occupy the even place, right? So you should not consider that case. So we'll consider the second point as, so number of ways in which so 5 letters which are R, O, U, G, H, right, can be arranged. So any 5 letters, number of ways in which any 5 letters can be arranged is factorial 5. So instead of R, O, U, G, H, if you take any other letters, so the number of ways will be factorial 5, right? Therefore, what is the question? So the probability that vowels may occupy even place. So what's the probability? So required probability is nothing but, so in how many ways 5 letters can be arranged? In factorial 5 ways. So out of factorial 5 ways, in how many ways vowels can be arranged along with the remaining letters? In factorial 2 into factorial 3 ways. This gives the probability, right? That's right. So which means, so the number of outcomes which are required divided by total number of outcomes, right? So required outcomes are 2 factorial into 3 factorial divided by total number of outcomes are 5 factorial, right? So we can totally in 5 factorial ways, you can arrange these 5 words, right? So which includes even the one of the vowels in the first place also, in the odd place also, right? So out of these ways, 5 factorial ways, so only 2 factorial into 3 factorial ways can give the vowels at even places, right? So vowels at even places, right? Which is nothing but required outcomes. Required outcomes and the total number of outcomes. So total outcomes are 5 factorial ways. So in the total number of ways in which all the 5 figures, for all the 5 letters particularly can be arranged, right? Both in even and odd places, right? So which is factorial 5. Therefore, the required probability is 2 factorial into 3 factorial by 5 factorial. So on simplification, you will get 2 factorial as 2, 3 factorial is 6, 5 factorial is, so 5 into 4 into 3 into 2 into 1. Here, 3 into 2 into 1 is nothing but 6. 6 and 6 will get cancelled. So 2 into 2 is 4. Therefore, we have 1 by 10 is the probability, right? Come back to the question here. So look at the options. 1 by 10. Option A is the right answer. Question number 2. A cubical dice is thrown 6 times. The probability that 2 and 4 will turn up exactly 3 times each is given by. Here students, a cubical dice is thrown 6 times. In that we have to choose 3 times. Right? Choose 3 times. Right? Here we are going to the concept of combination. In how many ways we can choose 3 times? So for example, a cubical box, a cubical dice. So we are taking, it is thrown 6 times, right? So we have to choose 3 times such that in that probability of getting 2 3 times, also probability of getting 4, phase 4 3 times. Right? So before going to the probability, let us go to the combinations, right? So ways of getting 3 times out of 6 times, 3 times top phase, right? Ways of choosing, right? Ways of choosing 3 times out of 6 times is equal to, for example, this is first time the dice is thrown, second time, third time, fourth time, fifth time, and sixth time, right? So you can choose first, second, and third times. These continuous three trials, right? To choose 3 times, right? Or you can choose first, third, and fourth, or you can choose first, fourth, and fifth. So first, fifth, and sixth trial, right? So to choose the top phase, so there are many ways. So these ways of choosing 3 times out of 6 times is equal to 6C3. So these are the combinations of choosing 3 times, right? In that probability of getting 2, right? So in that probability of getting 2 as top phase. 2 as top phase. So we are going to use the formula probability is equal to number of favorable outcomes divided by total number of outcomes. So we know the formula probability is equal to, so number of favorable outcomes divided by total number of outcomes, total outcomes, right? So here probability of getting 2 as a top phase. So probability of getting 2 as top phase. So if once the dice is thrown, so one phase will be 2, which is top phase, for example, right? So out of 6 phases, right? So into another time if it is thrown, again if we get 2 as top face, so it becomes into 1 by 6, into 1 by 6. These are the 3 times we are getting 2 as top face. Therefore, total probability of getting 2 as top face is 1 by 6 raised to 3. Right? 1 by 6 raised to 3. Similarly, probability of getting 4 as top face. Probability of getting 4 as top face. Right? So, if once dice is thrown, if you get 4 as top face, the probability becomes 1 by 6 into, again if it is thrown, if we get 4 as top face, so it will be 1 by 6 into 1 by 6. Again it is 1 by 6 raised to 3 is probability of getting 4 as top face. Right? Therefore, come back to the question, probability that 2 and 4 will turn up exactly 3 times. Right? Therefore, required probability is equal to, before going to take the probability of getting a face, right, as top face, the 3 times each. So we have to take ways of choosing 3 times out of 6 times. Because, so dice has been thrown 6 times here. So in that we have to choose only 3 times, right? So ways of choosing 3 times out of 6 times, which is 6C3 into probability of getting 2 as top face into probability of getting 4 as top face, which are 1 by 6 3 into 1 by 6 3. Right? Therefore, the answer is 6C3 into 1 by 6 cube into 1 by 6 cube. Right? So here among the given options, so we have the answers in the form of fractions. Right? So we'll convert the 6C3 into a whole number. 6C3 factorial 6 divided by 3 factorial into 6 minus 3 factorial. We are using NCR formula, factorial n by r factorial into n minus r factorial. This formula, right? So whereas 6 cube is, we'll leave as it is, into 1 by 6 cube. Right? Simplify this, you will get the answer. Right? So here, so factorial 6 can be written as 6 into 5 into 4 into 3 into 2 into 1. We'll write it as factorial 3 divided by factorial 3 into factorial 3, since 6 minus 3 is 3. Right? Now, moving further, 1 by 6 cube into 1 by 6 cube. Here 3 factorial is 6, so we can cancel 6 and 6, and also 3 factorial and 3 factorial. We have 20 divided by 6 cube. 6 cube into 6 cube. So you will get, so 216 into 216. So 46,656. So 20 by 46, both the numbers are divisible by 4. So 4 into 5 is 20, and 46,656 by 4 is 11,664. This is the probability of getting, probability that 2 and 4 will turn up exactly 3 times. Right? Each. So is equal to 5 by 11,664. Option A is the right answer. 5 by 11,664. Question number 3. The answer sheets of 5 engineering students can be checked by any one of 9 professors. What is the probability that all the 5 answer sheets are checked by exactly 2 professors? So for the better understanding of this, we'll consider the answer sheets. So here are 5 answer sheets. We'll consider these as answer sheets are 5. Right? So are checked by any one of 9 professors. We'll consider 9 professors. So 3, 4, 5, 6, 7, 8, 9. Right? So professors are 9. Number of professors. Right? So here the question is the probability that all the 5 answer sheets are checked by exactly 2 professors. Here all the sheets, right? So they need to be checked by right? 2 professors. So for that, we have to consider the ways of checking all these 5 answer sheets by all the 9 professors first, right? So in that, we have to choose any two professors. So for that, we have to take the ways of choosing only 2 professors out of 9 professors. You can choose first and second professor, or third and fourth professor, or any 2 professors, right? Therefore, we need to take ways of choosing professors, right? So after taking ways of checking all the answer sheets by all the professors, after this step, we have to take ways of choosing 2 professors, because we need only 2 professors here. So after that, so ways of checking 5 answer sheets by 2 professors, right? So we'll go step by step now, right? Here, students. So first we'll consider ways of checking all the 5 answer sheets, all 5 answer sheets by all 9 professors, is equal to, here each paper 1 is checked by each professor, right? In 9 ways it is checked, right? Each paper is checked in 9 ways. So we'll consider first paper is checked in 9 ways into, so when it comes to ways of checking or ways of taking, so therefore in this case we have to multiply the ways, right? So here the second paper is also checked by each professor, right? Therefore in 9 ways the second paper is being checked. Therefore it is into 9, into third paper is also checked by 9 times, into 9, right? So it is repeated 5 times, not 9 times, because there are 5 answer sheets, right? Third paper is also checked by 9 times. Fourth paper is also checked 9 times, right? Therefore 9 raised to 5. Here 9 is nothing but number of times each paper is checked, and 5 is nothing but number of sheets, right? So which means ways of checking all 5 answer sheets by all nine professors, right? So let us consider number of ways of choosing 2 professors, because we don't need all 9 professors, right? So number of ways of choosing 2 professors. 2 professors out of how many professors? Out of 9 professors, right? So which is equal to 9C2 ways. In 9C2 ways, we can choose 2 professors. That means you can choose last 2 professors for the correction, or before last 2, right? Or first 2 professors, or second and third professors, right? So in many ways, you can choose 2 professors. The ways are 9C2 ways. In these many ways, you can choose 2 professors, right? Let us consider, so ways of checking these 5, the given 5 papers by 2 professors, not by all 9 professors, by 2 professors. So ways of checking, right, all 5 papers by 2 professors. So as in the first case, so it is ways of checking all 5 answer sheets by all 9 professors we have taken. Here by only 2 professors we are taking, right? So for that we'll consider 5 sheets, answer sheets, right? So by 2 professors. So that means each paper is checked by each professor here. First paper is checked by 2 professors, right? So second paper is also checked by 2 professors. Third paper is also checked by 2 professors. Fourth is also checked by 2 professors. And fifth paper is also checked by 2 professors, right? So in 2 ways, each paper is being checked, right? In 2 ways. Therefore, first paper is checked in 2 ways. into second paper is checked in 2 ways, right? Into third paper is checked in 2 ways. Fourth paper into fifth paper is checked in 2 ways. So minus. So there is a possibility that the single teacher can check one paper, right? Since there are two teachers here, two professors here, right? So two professors here. So minus 2, this minus 2 indicates, so there are two ways of checking, by single professor. That means either by first professor or second professor. Two ways of checking by single professor. Therefore, so 2 raised to 5 is minus 2 is nothing but ways of checking all 5 papers by 2 professors, right? Here the question is probability that all the 5 answer sheets are checked by exactly 2 professors, right? So before going to probability, so here ways of checking 5 papers, right? So here we have chosen 9C2 ways, 2 professors in 9C2 ways, right? So this indicates, so 2 raised to 5 minus 2 indicates, right? So ways of checking 5 papers. Therefore, ways of checking 5 papers is equal to 2 raised to 5 minus 2. These are the ways of checking 5 papers by 2 professors. But we have an option here, right? So we can choose 2 professors in these many ways, 9C2 ways, right? Into 9C2. Into 9C2 gives total ways of checking 5 papers, right? So here, this 2 raised to 5 minus 2 is pertaining to only 2 professors. It may be first and second and third. So pertaining to only one case. But we have these many cases, 9C2 ways of choosing the professors itself, right? Therefore, their product use total ways of checking 5 papers. Come back to the question, probability that all the 5 answer sheets are checked, right? Therefore, the required probability is equal to, so by the formula it is favorable outcomes divided by total number of outcomes, right? So I'm mentioning even the formula also, favorable outcomes divided by total number of outcomes. Here, total number of outcomes is nothing but, so total number of ways of checking all 5 answer sheets by all 9 professors. This is the total way, right? So which is 9 raised to 5. In how many ways all the sheets can be checked by all the professors? In that, total ways of checking 5 papers by 2 professors. There are 2 raised to 5 minus 2 into 9C2 ways of checking 5 papers by only 2 professors, right? Therefore, simplify it. Look at the options. So options are in terms of fractions. Therefore, we'll simplify this part. So 2 raised to 5 minus 2. So 4 into 2, 8 into 2, 16 into 2, 32, minus 2 is 30, into 9C2 is factorial 9 by 2 factorial into 9 minus 2 factorial is 7 factorial, whole divided by 9 raised to 5, right? So 30 into 9 factorial is 9 into 8 into 7 factorial by 2 factorial into 7 factorial. Here we can cancel 7 factorial and 7 factorial. And 2 into 4. 2 into 4 is 8 divided by 9 raised to 5. So still we can simplify 30 into 9 into 4 is 36 by 9 raised to 5. Right? So 30 into 36 by 9 into 9 raised to 4. So that we can cancel 1 9 here. 9 into 4 is 36. So we'll have 120. 30 into 4 is 120 by 9 raised to 4. 9 raised to 4 is nothing but 6,561. Right? 6,561. Right? So therefore, since 6 plus 6 is 12, 12 plus 18, both the numbers are divisible by 3, right? So 3 into 40, 3 into 2, 3 into 1. Then 3 into 8. Then 3 into 7. Again, this can be divisible, cannot be divisible by, right? 40 by 2187. Is this the answer? Yes. Yes. So 40 by 2187. Right? So total number of ways of checking all the 5 papers by 2 professors is 40 by 2187. Option B is the right answer. Question number 4. If a letter is selected at random from the letters of the word management, what is the probability of the letter selected being are repeated letters? So here, so the letters in the given word are M-A-N-H-E-M-E-N-T, right? These are the letters in which the letter M is repeated, right? The letter M is repeated once, and also the letter A is repeated. N is also repeated, right? A is repeated. Then the letter N is repeated. Next comes letter E, right? E is also repeated. So here the 4 letters are repeated here, right? So we need to find the probability of the letter, right, drawn at random, right, is a repeated letter, is nothing but favorable outcomes by total number of outcomes. Here total outcomes is nothing but total number of letters in the given word, right? So we'll consider that. So total number of letters in the given word, there are 1, 2, 4, 6, 8, 10 letters. In the given word management, there are 10 letters. In that, number of letters, right? So which are repeated. Here, 4 letters are repeated. So which are M, A, N, and E. These 4 letters are repeated, right? M, A, N, and E, right? Therefore, the required probability, right? Required probability means a probability of a letter selected being a repeated letter is equal to, when it is drawn randomly, right, is equal to, so favorable outcomes, again the same formula. Here favorable outcomes are nothing but, so number of repeated letters, right? So which is 4 divided by total outcomes. Total number of outcomes. Total number of outcomes is nothing but total number of letters here. 4 by 10, which is nothing but 2 by 5 is the probability, right? So out of 5, when the letters are drawn randomly, 2 letters will be the repeated letters, right? Therefore, option D is the right answer. Question number 5. A can hit a target 4 times in 5 shots. B can hit 3 times in 4 shots. And C can hit twice in 3 shots. When they fire together, what is the probability that at least 2 shots hit the target? So at least 2 shots hit the target. What is the probability, right? So for that, so we'll consider, so probability that A can hit a target, right? Here, A can hit 4 times in 5 shots, right? So we'll consider, we'll just make a small table here, right? So here we'll consider the probability of hitting by A, right? By B, we'll consider separately these probabilities. By C, right? First, we'll consider the probability of hitting by A is, So out of 5 shots, A can hit four shots, right? So A can target 4 times. Therefore, the probability is favorable outcomes by total outcomes, which is 4 by 5. So total shots are 5. In that, he can target 4 shots, 4 times, right? So students, so total outcomes, right? Total outcomes are 5 shots, total number of shots, and favorable outcomes here by total outcomes. Here favorable outcomes are nothing but number of targets, right? So outcomes gives probability, right? So probability of hitting by A is 4 by 5. Whereas probability of hitting by B is, B can hit 3 times, right? Out of 4 shots. Therefore, probability is 3 by 4. Whereas C can hit twice, 2 times in 3 shots, right? These are the probability of hitting by A, B and C respectively, right? So we'll consider probability of not hitting by them, right? Probability of not hitting. So out of 5, if he can target 4, so what is the remaining target or remaining shot? Only 1, right? So 1 out of 5 he cannot target, right? 1 out of 5 he cannot target. A cannot target. Whereas out of 4 he can target 3. Therefore, the remaining one, right, is the remaining one he cannot target. It is 1 out of 4. Right? And in the third case, in the case of C, out of 3, he can target 2. Therefore, the remaining 1 cannot be targeted by C. These are the probability of not hitting by them. So here come back to the question. If they fire together, what is the probability that at least 2 shots hit the target? At least 2 shots means there are 3 cases separately, right? So in first case, A and B can hit the target, not C. So that at least 2 hit the target here. 2 persons hit the target. A and B hit the target, not C, right? So in the second case, B and C can hit the target, not A, right? And in the third case, A and C can hit the target, not B, right? So we'll consider the respective probability, right? So probability of hitting by A is 4 by 5 into by B is 3 by 4. Probability of not hitting by C is 1 by 3 into 1 by 3, right? So in the second case, probability of hitting by B is 3 by 4 into by C is 2 by 3 into not hitting by A, which is 1 by 5, right? So we'll consider the third case. So probability of hitting by A is 4 by 5, by C is 2 by 3, right? Right? Not hitting by B is 1 by 4, right? Therefore, their respective probabilities are, right? So that at least 2 shots hit together. The respective probabilities are here 4 and 4 will get cancelled, 3 and 3 will get cancelled, which is 1 by 5, right? So there is a one chance of hitting a target, right? So either A or B, not C, right? And in the second case, right, there is a chance of, so 3 and 3 will get cancelled, 2 into 2. So there is a chance of hitting a target 1 time out of 10 shots, right? So whereas when A and C hit the target, not B, the probability becomes 4 and 4 will get cancelled. So it is 2 by 15 is the probability, right? So what is the total probability or required probability that at least 2 shots hit the target, right? Required probability that it is understood that at least 2 shots hit the target. So just add this, right? 1 by 5 plus 1 by 10 plus 2 by 15, right? So these are the probability that at least 2 can hit the target, right? So in 3 different situations, So we just take the sum of these. So here 30 is the LCM, So numerators becomes here 5 into 6, therefore it is 6. So 10 into 3, therefore 1 into 3 is 3. So 15 into 15 into 2, therefore 2 into 2 is 4. Therefore 13 by 30 is the probability that at least 2 shots hit the target, right? 13 by 30 is the probability. Hence option A. Question number 6. 2 dice are thrown simultaneously. The probability of obtaining a total score of 5 is. So students, 2 dice are thrown simultaneously. In how many ways 2 dice can be thrown? So we'll consider 2 dice, right? Right? So in how many ways 2 dice can be thrown? Here 1 dice can be thrown in 6 ways, right? Because it has 6 faces like this. So we'll consider 1, 2, 3, 4, right? 5 as the bottom and 6 as the back face, right? So in 6 different ways dice can be thrown, right? So one of the ways is as 3 as top face, another way is as 2 as top face, another way is as 4 as top face. So 1 can be top face and 5 can be top face, right? So here even the 6 face 6 can be the top face, right? So these are the different ways of throwing a dice. In 6 ways a dice can be thrown, right? Similarly for the second dice, so second dice can be thrown in 6 ways, right? Here the total number of ways in which 2 dice can be thrown is nothing but 6 into 6 ways. Totally in 36 ways 2 dice can be thrown, right? So these 6 ways are, so if you take 3 as the top face, in another dice you can take 4 as the top face. For each face of one dice there are 6 combinations for other dice. 6 combination for each face of one dice, right? Therefore for all 6 faces, so there will be 6 combination. Therefore it is 6 into 6, right? 6 into 6. Therefore, or you can add 6 times 6, right? So you'll get the same answer. Therefore, total ways of throwing 2 dice is equal to 6 into 6, which is equal to 36 ways, right? Here the question is probability of obtaining a total score of 5 is given, right? So to obtain total score of 5, so if you get 3 as the top face, for example, right? So in another top face, you have to get 2, so that total score becomes 5. Total becomes 5, right? So if you get 1 as the top face in dice 1, you have to get 4 as the top face in dice 2. So that total becomes 5, right? So in another way, if you get 4 as the top face in one dice, you have to get 1 as the top face, right? So that total becomes 5, right? Similarly, if you get 2 as the top face in dice 1, you have to get 3 as the top face in dice 2. So that total becomes 5. So in these 4 ways, you can get these values so that the total score becomes 5. If you get 5 in one of the dices, 5 as top face, right? If you get 1 also in another dice, it total becomes 6, right? According to the question, this condition doesn't hold, right? Because the total score should be 5 here. Therefore, these are the 4 ways of getting total score of 5, right? Therefore, so ways of getting total score of 5 is equal to how many ways? There are 4 ways, right? Therefore, probability of obtaining total score of 5. Therefore, required probability again by the formula. So number of favorable outcomes divided by total number of outcomes. Here total number of outcomes are nothing but, so total ways of throwing 2 dices, right? In the numerator, it is ways of getting score 5, right? Ways of getting score of 5 gives the required probability. Therefore, probability of getting the score of 5 is 4 ways divided by total number of ways are 36 ways, right? Therefore, it is 1 by 9 is the probability. Therefore, option C is the right answer, right? So, out of 9 throws, 1 by 9 means out of 9 throws, you can get 1 in 1 throw, the score will be equal to 5, right? In 1 throw, the score will be equal to 5. So, together, from dice 1 and dice 2. Therefore, for the given question, option C is the right answer. Question number 7. 2 cards are drawn from a pack of cards one after another so that the first card is replaced before drawing the second card. What is the probability that the first card is King of Club and the second card is a black card? So in a pack of cards, so how many cards will be there in a pack of cards? There are 52 cards, right? 52 cards in one pack. Right? So here we need to find probability that the first card is King of Club. So after drawing 2 cards, so what's the probability of getting one card as King of Club? How many King of Club cards will be there in a pack of cards? So there is only one King of Club, right? One King of Club. Right? Therefore, probability of getting a King of Club is 1 out of 52 cards. There is only one possibility or one probability of getting King of Club, and probability of getting black card, right? For that we need number of black cards, right? How many black cards will be there in a pack of 52 cards? There will be 26 black cards will be there in a pack, right? Therefore, probability of getting black card is 26 out of 52. Right? For all this, we are using probability formula, which is probability is equal to number of favorable outcomes divided by favorable outcomes divided by total number of outcomes. Total number of outcomes. Based on this formula, we are going to solve this, right? Here, let us find probability of getting King of Club. Right? So probability of getting King of Club. King of Club. So which is equal to, so favorable outcomes are total number of King of Club cards. There is only one, right? King of Club divided by total number of outcomes. Here favorable outcomes is one King of Club, right? It is only one, and total number of outcomes is nothing but total number of cards. So 1 by 52, 1 out of 52, right? Probability of getting King of Club is only one. There is only one chance of getting King of Club, right? Then probability of getting black card, right? So after first card, the second is a black card, right? Therefore, probability of getting black card. So there are 26 cards. So number of favorable outcomes are 26 out of 52, out of total number of outcomes, right? 26 by 52 is the probability of getting black cards, right? So here the question is 2 cards are drawn from the pack of cards. So we need to draw 2 cards. So first card should be a King of Club and second card should be a black card, right? Therefore, required probability of getting 2 cards, the condition is already given, right? Such that one card is King of Club, another next card will be black card, is equal to 1 by 52, right? 1 by 52 into 26 by 52. This is the probability, right? Therefore, so simplify, 26 by 52 is 1 by 2, right? Therefore, 1 by 104, right? 1 by 104. So we have multiplied. So 52 by 2, it is 104. So one required probability is 1 by 104, option C. Question number 8. A box containing 6 red, 7 black and certain number of green balls. If the probability of getting red balls is 1 by 4, then the number of green balls in the box are. So it's an easy question. So we'll consider a box in which there are 6 red balls, then 7 black balls and certain number of green balls. Let the number of green balls be x number of green balls, right? So probability of getting red balls is 1 by 4. So we'll consider probability is equal to, so favorable outcomes by total number of outcomes, right? Favorable outcomes by total number of outcomes, total outcomes. Here, probability of getting red balls is 1 by 4. Probability is 1 by 4, which is equal to, so what is probability of getting red ball? So total number of balls. Here, total outcomes are, so 6 plus 7 plus x. In that, how many are red? 6 balls are red, right? Therefore, so number of red balls by total number of balls, right? Number of red balls by total number of balls gives the probability of getting a red ball, right? Therefore, number of red balls are, there are 6 red balls out of 6 plus 7 plus x number of balls. Total balls are 6 plus 7 plus x, which is equal to probability of getting red ball, which is 1 by 4. Simplify it. 6 plus 7 plus x is equal to 6 into 4, which is 24. Therefore, x is equal to 24. Here 6 plus 7 is 13. It becomes minus 13. Therefore, x is equal to 11. Therefore, the number of green balls are 11. There are 11 green balls in the box. Option D. Question number 9. A coin and a dice are thrown. If A denotes an event, head and odd face, and if B denotes an event, tail and even face, then probability of getting A plus probability of getting B is. So let us consider two events, right? A and B, right? A and B events. So in which a coin and dice are thrown. So we'll consider a coin and a dice are thrown, right? So here, so there are 2 faces for a coin, right? And there are 6 faces for a dice. So keeping this in our mind, so consider event A. So A denotes an event, head and odd face. So we'll consider head, right? And odd face. Odd face. So how many heads are there in a coin? There is only one head, right? So we'll consider the probability, right? So here I am making a small table here. So instead of writing in a lengthy lines, so it is better to take a small table here, right? So here probability means probability of getting head in a coin is nothing but, so 1 out of 2, right? So here again we are using the formula probability is equal to favorable outcomes divided by total number of outcomes, right? Favorable outcomes by total outcomes. Total outcomes. Here favorable, in this case, in case A, favorable outcomes are number of heads in a coin. There is only one head, and total outcomes are the total faces. There are 2 faces, right? So number of getting or probability of getting head in a coin is 1 by 2 or 1 out of 2. And odd faces. So how many odd faces are there in a dice? There are 3 faces, 3 odd faces out of total faces. Total faces are 6. Therefore, probability of getting an odd face is 3 out of 6, right? 3 out of 6. Therefore, so the probability of getting a head face and odd face, right? Therefore, total probability. Total probability, we are focusing only the event A, right? So total probability of getting a head and an odd face is equal to 1 by 2 into 3 by 6. 3 by 6 itself is 1 by 2. Therefore, we have 1 by 4 as the probability. Total probability of getting a head and odd face, right? 1 by 4. Consider the second case here. So second event, right, in which probability of getting a tail and even face. How many tails are there in a coin? There is only one tail, right? And even faces are 3. 2, 4, and 6 are the even faces, whereas 1, 3, and 5 are odd faces, right? Therefore, consider the probability. Probability of getting a tail and an even face. So probability of getting a tail is 1 by 2, right? 1 by 2 into probability of getting an even face is 3 by 6. So 3 by 6 means favorable outcomes by total number of outcomes. Again, it is 1 by 4. Since 3 by 6 is 1 by 2, so total probability. So we'll consider total probability is equal to 1 by 4. Total probability. Right? So come back to the question. Here we need to find probability of A plus probability of B. Probability of case A plus probability of case B. Right? Therefore, probability of case A plus PB. Probability of B is equal to. So in case A, the probability is 1 by 4. Right? So out of 4, so there is only one chance of getting a head and odd faces. Plus 1 by 4 is probability of case B. That means out of 4, there is only one chance of getting a tail and even face, an even face, right? Therefore, that means if a coin and cube both are thrown, here I am focusing on 1 by 4, this 1 by 4. Probability of getting a head is only 1, right? Only 1, and there is only one chance of getting odd face, right? Therefore, 1 by 4 is the probability, plus 1 by 4 is for the second case. So it is 2 by 4, nothing but 1 by 2, right? 1 by 2 is the answer, option D. Question number 10. 6 playing cards are lying face down on a table where 2 of them are kings. 2 cards are drawn at random. Let A denote the probability that at least one of the cards drawn is king, and B denote the probability of not drawing a king. Then the ratio A to B is. So here, students, let us consider 6 cards, right, lying face down on a table. We'll consider 1, 2, 3, 4, 5, 6 cards, right, for the better understanding, where 2 of them are kings. So in that, 2 of them are kings. When 2 cards are drawn at random, right, so a probability of at least one of the cards drawn is king. Before going to the probability, so we'll consider in how many ways two cards can be drawn at random, right, out of 6 cards, right? In how many ways 2 cards can be drawn, right? In that 2 cards, right, in how many ways at least one of the cards can be drawn is king, right? So we'll go step by step. So in first step, we'll take the number of ways in which 2 cards can be drawn, right? Number of ways in which 2 cards can be drawn. 2 cards can be drawn is equal to, so there are 6 playing cards, right? So out of 6 cards, we have to draw 2 cards. Therefore, it is 6C2, right? So 6C2 is nothing but, what's the value of 6C2? Factorial 6 by 2 factorial into 6 minus 2 factorial. So which is 6 into 5 by 2, right? So that we can cancel that factorial 4 parts. So you have studied this, all these permutation combination parts, right? So here it is in 15 ways we can draw 2 cards out of 6, right? So in 15 ways we can draw 2 cards. So here the question is let A denotes the probability that at least one of the cards drawn is king, right? So in how many ways at least one of the cards, so if you draw 2 cards, in how many ways at least one of the card will be king, right? So we'll consider ways of drawing king cards. Ways of drawing king cards. Drawing king cards. Right? And here let B denote the probability of not drawing king card. So simultaneously we will consider ways of not drawing king cards. Right? Because we are going to find the respective probability. Right? Therefore, we will consider ways of not drawing king cards. Not drawing king cards. Right? So you should keep in your mind that we are going to draw 2 cards, right? We are going to draw 2 cards. Here, come back to the ways of drawing king cards, right? Focus on king cards and we are going to draw 2 cards, right? So ways of drawing king cards, just imagine we are going to draw second and third cards, right? Second and third cards. In that, so at least one of the cards drawn is king. Right? So either card 2 is king or 3 is king. Right? So you can draw only one king card or you can draw both the cards or the cards which you have drawn are both the cards are king cards. Right? Therefore, in this also ways of drawing king cards, in this way also there are 2 ways. Right? So one is king, right? Both are king. Both are king cards, right? And one is king, right? So in the first case, so just imagine you have drawn second and third cards, right? Both the cards are king cards, king and king, right? King and king cards. So here, probability of getting king card, right? So before going to probability, we'll consider ways, right? So ways of getting king cards, right? So here, out of 2 cards which we have drawn, both the cards are king. Both the cards are king, right? Therefore, 2C2 is 1. There is only one way to draw both the cards as king cards, right? Right? So, in the second way, if one is king, right? If one card is king, so we have to, here it is given that 2 cards are drawn at random. So the probability that at least one of the cards drawn is king is asked, right? So both the cards can be king. In one way, we can draw both the cards, king cards. In another way, if one of the cards is king, right? And the remaining, another king card will be in the remaining cards, right? Here, 3 is not the king card, right? So this king card will be, so 4 or 5 or 6 or the first card. So in the remaining cards, the king card is there. So how to select the king card? In how many ways you can select the king card, right? So in the remaining cards. In the remaining cards. Therefore, so ways of getting king card. So if one of the cards drawn is king, so in how many ways one of the cards drawn or one of the cards can be drawn as king card? So out of 2, you can draw 1. So 2C1 is in 2 ways, right? You can draw, so 1 king card, right? So here in the remaining cards, so remaining 4 cards, right? So you can draw 4C1, right? 4C1, because you are going to draw only 1 king card, right? So therefore in 4C1 ways, you can draw king card. So 4C1 is nothing but 4. Therefore, 2 into 4, right? At least one of the cards is king. So in 8 ways, you can draw one king card. Right? Are you getting my points? Now come to the probability part, right? So part A. So here the probability that at least one of the cards drawn is king. It may be one card, a king card, or both the cards can be king. So required probability, we are using the formula of probability. So the favorable outcomes by total outcomes, right? Probability here, favorable outcomes are, so number of ways in which at least one card is king. One card is king, right? This is the favorable outcome divided by total number of outcomes. Here total number of outcomes means total number of ways in which two cards can be drawn, right? So total ways of drawing two cards. Total ways of drawing two cards. Therefore, the probability is there are 1 plus 8 ways of drawing at least one card being king by total number of ways of drawing two cards is 15. Therefore, it is 9 by 15, which is nothing but 3 by 5. Right? So, come to the second case. So, part B. Right? So, in which we are going to find ways of not drawing king cards. So, not drawing king cards means, so just imagine second and third cards are king. Already two cards are king. We are not going to draw that. Right? So, ways of not drawing king cards are, so there are 4 remaining cards. Right? Remaining cards are 4. Remaining cards are 4. Right? In that way, we have to draw 2 cards. Right? Cards to be drawn is equal to 2. Right? Therefore, ways are, in how many ways 2 cards can be drawn out of 4? In 4C2 ways. 4C2 means factorial 4 by 2 factorial into 2 factorial. 2 factorial, one of the 2 factorials is here 4 minus 2 factorial, right? So here 4 into 3 by 2, which is 6. In 6 ways, 2 cards can be drawn in the remaining cards. That means which are not king cards, right? So now the question is, B denotes the probability of not drawing a king, right? Therefore, so probability of not drawing a king. That means number of ways in which the card drawn is not king card is 6 divided by total number of ways are 15. Therefore, it is 2 by 5. Right? 2 by 5. Now, the actual question is ratio of A to B. Right? Therefore, here A to B ratio. A is 3 by 5 whole divided by B is 2 by 5. Therefore, it is 3 by 2, which is 1.5. Right? The ratio is 1.5. Here the options are, here option, not C, option E, which is greater than or equal to 1.25. Here the ratio is greater than 1.25. Right? Therefore, option E is the right answer. Question number 11. In order to get at least once ahead with probability greater than or equal to 0.9, the number of times a coin needs to be tossed is, right? So in a coin, there are 2 faces, right? So in that, one of the faces is head, right? So we'll consider probability of getting head in a coin is 1 by 2, right? So I'll mention step by step. Probability of getting a head in a coin is 1 by 2, right? Because there is only one head, right? You can get the head phase in only one way, right? Either you can get head or tail. Therefore, probability of getting a head is 1 by 2. When it is 1 by 2, when a coin is tossed once, right? So when coin is tossed once, tossed once. Right? Here we need to find the number of times a coin needs to be tossed. Right? So for that, we'll consider when a coin is tossed n times. Right? What is the probability of getting a head? So when coin is tossed n times, probability becomes, probability, I'll write in short, probability of getting a head becomes 1 by 2 into 1 by 2 into 1 by 2, so on up to 1 by 2, which is nth time, right? Nth time, n times, right? Therefore, it becomes 1 by 2 to the power of n or 1 by 2 raised to n. Both the same, right? 1 by 2 to the power of n, right? N times the coin is tossed, right? Therefore, probability of getting a head is 1 by 2 raised to n. Here it is given that the probability is greater than or equal to 0.9. Right? So it is greater than 0.9 or equal to 0.9. Right? I'll read out the question once again. In order to get at least once ahead with probability greater than or equal to 0.9, the number of times the coin needs to be tossed. Right? In general case, the number of times coin needs to be tossed is 1 by 2 raised to n, but it is given that probability is greater than or equal to 0.9. Right? So just imagine a case in which probability is 0.9, right? Probability of getting a head, probability is equal to 0.9. In that case, you cannot directly write 1 by 2 raised to n is probability of getting a head when n times the coin is tossed. 1 by 2 raised to n as point is equal to 0.9. You cannot write like that, right? So if n is equal to 1, this can, the 1 by 2 becomes 0.5, which is not equal to 0.9 and which is also not greater than 0.9, right? So in that case, so instead of taking 1 by 2 raised to n, so you have to consider 1 minus 1 by 2 raised to n, right? 1 minus 1 by 2 raised to n, this part is greater than or equal to 0.9. This can be equal to 0.9, right? So for example, 1 by 2 raised to n is, so for example, directly I am taking the value 1 by 2 raised to n. The value is 0.8, right? 0.8. So here, in that case, the given condition doesn't hold good, right? Therefore, we have to take 1 minus 1 by 2 raised to n is greater than or equal to 0.9, right? Therefore, here the number of times a coin needs to be tossed, we need to find the value of n here, right? Just simplify it. So here we just take this 1 by 2 raised to n to the LHS part, RHS part. So it becomes, here take this 0.9 to the LHS part, it becomes 1 minus 0.9 is greater than or equal to 1 by 2 raised to n, right? Or you can write 1 by 2 raised to n, this part is less than or equal to 1 minus 0.9, right? So 1 by 2 raised to n is less than or equal to 0.1, right? Right? So just rearrange this. So I'll take 1 by 0.1. Take this 0.1 to the LHS part. 1 by 0.1 is less than or equal to 2 raised to n. Take this 2 raised to n to the RHS part, right? I just interchange these two values. 1 by 0.1 is 10. 10 is less than or equal to 2 raised to n. Or 2 raised to n is greater than or equal to 10. Right? So here 2 raised to n cannot be equal to 10. Because you cannot express 10 in terms of 2 to the power of some value directly. Right? So 2 to the power of 3 is 8. Whereas 2 to the power of 4 is 16. Right? Which is greater than, right, 10, right? Therefore, so which is greater than or equal to 10, therefore greater than equal to 10 means this can be equal to 16, right? The least value which is possible is 16. Therefore, 2 raised to n is equal to 2 raised to 4, right? 2 into 2 into 2 into 4 is 16. Therefore, value of n is equal to 4, right? So here, the number of times the coin needs to be tossed is 4. 4 times the coin needs to be tossed to get at least once ahead, right? To get at least once ahead. So option B is the right answer. Students, if you want to practice this type of questions on probability, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 12. From a pack of cards, 2 are drawn at random, one by one with replacement. The probability that first is heart and second is king is. Very easy question, students. So if 2 cards are drawn at random, so probability that first card is heart and second card is king is. So number of cards, heart cards in a pack of 52 cards. So because in a pack of cards, there are 52 cards. So total cards are 52. Total cards are 52. In that number of heart cards are 13, right? There are 13 heart cards. And number of king cards are 4, right? There are 4 king cards in a pack of 52, right? Therefore, probability of getting a heart card is probability of getting a heart card. Getting a heart is equal to, here again we are using the same formula, number of favorable outcomes by total number of outcomes, right? So favorable card, your outcomes is nothing but getting a card, right? Favorable cards divided by total cards, right? So favorable cards are nothing but, so total heart cards in a pack of 52 are 13 by total number of cards are 52, right? So which is 1 by 4, right? Whereas number of getting a king, right? Probability of getting a king. Probability of getting a king, right? Here favorable cards are nothing but total king cards are 4, right? Out of 52 cards, total number of cards, right? Therefore, it is 1 by 13, right? 1 by 13 is the probability. Therefore, probability that first is heart and second is king is equal to, because we are going to draw 2 cards here, right? Therefore, required probability is equal to, so probability of getting a heart is 1 by 4, right? Into probability of getting a king is 1 by 13. Therefore, it is 1 by 52. 13 into 4 is 52, right? Right? So, therefore, option B is the right answer. Question number 13. There are 4 white and 4 black balls in a bag and 3 balls are drawn at random. If balls of same color are identical, the probability that none of them is black is. So here, students, let us consider the formula first. Then I'll explain the solution here. Probability is equal to favorable outcomes divided by total outcomes. Here, favorable outcomes are nothing but the number of ways in which we can draw 3 identical balls. That means not only 3 identical, so same colored balls, right? Here it is strictly given that, so the probability that none of them is black, right? So in how many ways we can draw only white balls? Particularly the number is 3, right? 3 white balls, right? So therefore the meaning of none of them is black is in how many ways or number of ways in which we can draw only white balls, right? Based on that, the given probability depends. Here, favorable outcome is nothing but, so ways of drawing three white balls. Three white balls divided by total ways of drawing three balls out of given 8 balls, right? There are 4 white and 4 black balls. So totally there are 8 balls. In that, in how many ways we can draw 3 balls, right? So ways of drawing 3 balls out of 8 balls. 3 balls out of total balls, right? Total balls. Here, weight of drawing 3 balls out of 4 balls, because we have 4 white balls, right? White balls. Out of 4 white balls, in 4C3 ways, we can draw 3 white balls, right? 4C3 ways, we can draw 3 white balls. Whereas out of 8 balls, we can draw 3 white balls in 8C3 ways, right? So therefore, the meaning of favorable outcomes by total number of outcomes is, so 4C3 by 8C3 ways, right? So total ways of drawing 3 white balls out of 4 balls divided by ways of drawing 3 balls out of totally 8 balls, right? So on simplifying, 4C3 is nothing but 4, whereas 8C3 is nothing but factorial 8, which is 8 into 7 into 6 into, we'll consider 5 factorial as it is, divided by 3 factorial into 8 minus 3 factorial is 5 factorial, so that we can cancel these two, right? So for NCR, we are using factorial n by r factorial by n minus r factorial. We are using this formula, right? So we'll simplify. 3 factorial is 6, we can cancel 6 and 6. So we have 4 by 56. 4 by 56 means 1 by 14, right? So the required probability that none of them is black is 1 by 14. Option B is the right answer, right? Therefore, option B. Question number 14. 3 dices are rolled. The probability that the same number will not appear on each of them is. So here students will consider 3 dices, right? So we'll consider 3 dices. So here we need to find the probability that the same number should not appear on each of them. For example, if 1 is the top face in first dice, right? Other than 1, the remaining numbers are 2, 3, 4, 5 and 6, right? There are 6 faces in a dice. So other than 1, the remaining numbers, it can be 2, 3, 4 on the top face of other dice, right? The second dice. Whereas in the third dice, the number on the top face should be other than 1 and 2, right? So it may be 6, 5, 4 or 3, right? So probability that the same number will not appear on each of them is. So before going to the probability, we'll consider the number of ways in which the sides of 3 dices can be arranged, right? We'll consider ways in which the sides of 3 dices can be arranged. In how many ways the sides of 3 dices can be arranged? Here consider dice 1, right? In how many ways these sides can be arranged? Consider side 1, which is top face. You can take this top face to left, right, bottom, top, front or back, right? In 6 different ways the side of, so we are focusing on one side, right? So one side of a dice can be arranged in 6 different ways, right? So whereas the second dice, right, we'll consider one side. So in 6 different ways, one side of a dice can be arranged. Also the third dice, in six different ways, one side of a dice can be arranged, right? Each dice has 6 faces, right? Each dice has 6 faces, right? Therefore, we need to take the product of these number of ways, 6 into 6 into 6, which gives total number of ways in which all the sides of 3 dices can be arranged. If you take plus sum of these 6 plus 6 plus 6, it gives the ways in which only one side from each dice, right? Only one side from each dice can be arranged in different ways, right? 6 plus 6 plus 6, it is 18. In 18 different ways, altogether 3 dices, so 3 faces can be arranged. But here we are taking all the sides of 3 dices, therefore it is product of 6, 6, 6, right? Therefore it is 6 cube ways. In 6 cube ways, we can arrange all the 6 sides of 3 dices, right? Here, in which the number of times the same number will appear on each of them, right? We'll consider number of ways in which same number appear on each of them. That means if you consider 1 now as the top face, in the second dice also there should be 1, and in the third dice also, right? So in all the 3 dices, the face should be same. One of the faces should be same, right? So if you take 2 as the right face, so in the second dice also 2 should be right face, and in the third dice also 2 should be right face, right? So in how many ways the same numbers will appear on each of them? In 6 different ways, right? In 6 different ways. If you consider, right? If you consider each side separately, in 6 different ways, the same numbers can appear on each of them. Therefore, we'll consider the probability that the same number will appear on each of them, right? So, probability that same number will appear on all the 3 dices is equal to, so by the formula favorable outcomes are nothing but, here favorable outcomes are nothing but, so ways in which same number will appear on each of them, right? There are 6 ways in which same numbers will appear each on them, divided by total outcomes. Total outcomes are nothing but total ways of arranging, right? Total ways of means 6 cube ways. Total ways of arranging the sides of 3 dices, right? Therefore, it is 6 by 6 cube, which is 1 by 36 ways. 1 by 36, not ways. 1 by 36 is the probability that the same number will appear on each of them. Here the question is, the same number will not appear. What is the probability? Therefore, required probability in which same number will not appear. Same number will not appear on each of them is equal to, since probability is always a fraction, right? So out of the total, so a small portion is called probability, right? When you consider out of total, say for example 90, so if you consider a small portion, it may be 35, this gives the probability, right? Therefore, so the required probability in which the same number will not appear is nothing but 1 minus 1 by 36, right? We are considering 1 as the whole, right? So that means 1 out of 1, whole out of whole is considered as 1, right? In which a small portion is taken out, right? So the meaning of this is 1 minus a small portion is taken out. That gives a probability in which same number will not appear is equal to 35 by 36. This is the probability, right? 35 by 36, option B, which indicates there is only one way. So this indicates 35 by 36 indicates there is only one way in which the same number will appear on each of them. In the remaining 35 ways, same number will not appear on each of them. Right? Therefore, so 1 matches with 1 in only one way. In the remaining 35 ways, 1 does not match with 1. Right? So instead of another 1, there may be some other numbers. Right? Therefore, option B is the right answer. Question number 15. If A and B are two events such that probability of A union B prime, this is A union B prime, there is a small correction, right? If probability of A union B prime is 5 by 6, probability of A is 1 by 4, that of B is 1 by 3, then A and B are. So here are 4 options. A and B are mutually exclusive, A and B are dependent, and A and B are independent. So here students, for two events A and B, right? So A and B are mutually exclusive when probability of A intersection B is equal to 0, right? So what is probability of A intersection B? So when two events are happening at the same time, two events A and B are happening at the same time, we'll take probability of A intersection B. That means two events are happening at the same time, right? When the probability of A intersection B is equal to 0, then the events A and B are mutually exclusive, right? So when events A and B are dependent, when probability of B by A into probability of A is equal to probability of A intersection B. Right? So that means, so the events A and B are whether they are dependent or mutually exclusive, even whether they're independent. So these situations depend on probability of A intersection B. Right? So here, when two events are independent, right, then probability of A into probability of B is equal to probability of A intersection B. Right? So the events A and B, so both the events are dependent on the probability of A intersection B, right? The value of A intersection B. So we'll find A intersection B first, right? So here probability of A union B prime is given. We'll find A union B, because to find A intersection B, probability of A intersection B, we use the formula probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B, right? Therefore, what is probability of A union B? It is 1 minus probability of A union B, the prime, right? Is equal to probability of A. What is probability of A given? 1 by 4 is the probability, plus that of B is 1 by 3, minus probability of A intersection B. Here 1 minus A union B prime is given 5 by 6 is equal to, here we'll take the LCM, is 12, and the numerator becomes 3 plus 4 minus probability of A intersection B, right? Therefore, we'll simplify it. Here 1 minus 5 by 6 is 1 by 6 is equal to 7 by 12 minus probability of A intersection B. Therefore, probability of A intersection B is equal to 7 by 12 minus 1 by 6. Since 12 is the LCM, numerator becomes 7 minus 2. Therefore, probability of A intersection B is 5 by 12. 5 by 12, right? Now, depending on the value of A intersection B, probability of A intersection B, so we have to decide whether A and B events are mutually exclusive or dependent or independent, right? Here probability of A intersection B is not equal to 0. It is equal to 5 by 12. Therefore, it is not mutually exclusive, right? Option A is not the answer. Consider option B, whether they are dependent or not. Here probability of B by A. What is the value of probability of B by A? It is equal to probability of A intersection B or B intersection A, right? So probability of A intersection B or B intersection A divided by probability of A, the event in the denominator, which is A, right? Therefore, here A intersection B, just now we have calculated for as to 5 by 12. So 5 by 12 divided by probability of A is 1 by 4. Simplify it, 5 into 4 by 12, which is equal to, right? So which is equal to 5 by 3 is the value of probability of B by A, right? So we'll consider probability of B by A into probability of A, right? So which is 5 by 3 into probability of A is 1 by 4, right? Which is equal to 5 by 12, which is nothing but probability of A intersection B, right? So product of probability of B by A and probability of A is probability of A intersection B. Therefore, the events A and B are dependent events. Both are dependent, right? So probability of B by A into probability of A is probability of A intersection B. Hence, two events are dependent. Option B is the right answer. Question number 16. A basket full of fruits containing 13 apple and 13 oranges. A person draws 2 fruits from the basket. What is the probability that the 2 fruits are the same? Right? A basket contains 13 apples and 13 oranges. Right? When a person draws 2 fruits from the basket, the probability that the 2 fruits are the same, right? They are the same means 2 fruits are either apples or oranges, right? That means 2 fruits are of the same variety, right? So either apples or oranges. For that, we'll consider the required probability is equal to, right? So ways of drawing 2 fruits of the same quality, right? So ways of drawing two fruits. Here, the favorable outcome is 2 fruits of same type. 2 fruits divided by total ways of drawing 2 fruits out of total number of fruits, which is 26. Total ways of drawing 2 fruits out of 26 fruits. That means total fruits, which is nothing but, here we'll consider ways of drawing 2 fruits of the same type. So here are 13 apples and 13 oranges, right? So we'll consider first case. So either you have to draw 2 apples or 2 oranges out of 13 apples and 13 oranges, right? So here ways of drawing 2 apples out of 13 apples is nothing but 13C2, right? So you can draw 2 apples from 13 apples in 13C2 ways, right? And also you can draw 2 oranges out of 13 oranges in 13C2 ways. Therefore, together it is 13C2 plus 13C2 ways, right? So these are the total ways of drawing 2 fruits of the same type, right? In 13C2 plus 13C2 ways divided by total ways of drawing 2 fruits out of 26 fruits is 26C2. In 26C2 ways, we can draw 2 fruits, right? Maybe they are of same type or may not be, right? Here, 13C2 is nothing but factorial 13 by 2 factorial into 13 minus 2 is 11 factorial plus 13 factorial by 2 factorial into 11 factorial divided by 26C2. 26 factorial divided by 2 factorial into 26 minus 2 is 24 factorial. Therefore, we can write 13 factorial by 11 factorial as 13 into 12. so that the remaining part in 13 factorial will get cancelled with 11 factorial. Divided by 2 factorial is 2 plus 13 into 12 by 2 whole divided by, here in the denominator part we can write 26 into 25 and the remaining parts are nothing but 24 into 23 so on up to 1. That part will get cancelled with 24 factorial in the denominator. Divided by 2 factorial is 2, right? So we have 2 into 6 is 12. So 13 into 6 is 78 plus in the next part also we have 13 into 6 which is 78 divided by, here we have 12 into 13. So that 13 into 25 becomes, so 25 into 3 is 75. So 25 into 1 is 25 plus 7 is 32. 325, right? So that means in 325 ways, we can draw 2 fruits out of 26 fruits. And in 78 ways, we can draw 2 fruits out of 13 apples. And in 78 ways, we can draw 2 fruits out of 13 oranges. So totally it is 78 plus 78, which is 156 by 325 is the required probability, right? So both the numbers are divisible by 13, I think, right? 13 into 1 is 13, 13 into 2, right? It's 12 by 13 into 2, 26, then 13 into 5, 65. So 12 by 25 is the required probability that the 2 fruits are of the same type, right? Either oranges or apples. So option D. Question number 17. What is the probability of yielding the minimum amount when 2 coins are selected simultaneously at random from a piggy bank containing 4 1 rupee coins, 3 2 rupee coins and 3 5 rupee coins? So students will consider, right, a piggy bank which contains 4 1 rupee coins, right, and 3 2 rupee coins and 3 5 rupee coins. 3 5 rupee coins, right? So probability of yielding the minimum amount. So here, so ways of yielding the minimum amount we'll consider, right? In how many ways we can get minimum amount, right, from the piggy bank. So in how many ways we can get minimum amount? So here are 4 1 rupee coins, right? 1 2 3 4, right? If you draw the both the coins as 2 rupee, 1 rupee coins, then only you will get the minimum amount, right? So ways of yielding minimum amount are, so 4C2 out of 4 1 rupee coins, we have to pick 2 1 rupee coins, which is 4C2, right? Therefore, required probability is, right, ways of yielding minimum amount divided by total ways of selecting 2 coins, right? I'm focusing on 2 coins, right? Therefore, we'll consider probability, right, is equal to, right, ways of selecting 2 coins to get minimum amount divided by ways of selecting, right, 2 coins, ways of selecting 2 coins out of how many coins given? 4 plus 3 plus 3, right? Out of 4 plus 3 plus 3 coins, which is 10 coins, right? So this gives the probability of yielding minimum amount, right? Ways of selecting 2 coins to get minimum amount is, so select 2 coins out of 4 1 rupee coins, which is 4C2, divided by ways of selecting 2 coins out of 10 coins, which is 10C2, right? So out of these ways of selecting, you have to consider ways of selecting which yield minimum amount only, right? That means, so you can choose first and second 1 rupee coin, or second and third 1 rupee coin, or third and fourth 1 rupee coin, or first and fourth, or first and third, or second or fourth, like that, right? So these ways are nothing but 4C2 ways, right? So in these many ways, you can get minimum amount, right? Therefore, 4C2 is nothing but 4 factorial by 2 factorial into 2 factorial, right? We know the formula that NCR is factorial n by factorial r into n minus r factorial. Using this formula, we are going to solve, right? So whereas 10C2 is factorial 10 by 2 factorial into 10 minus 2 factorial, which is 8 factorial. Simplify it. So in 4 factorial, you can take 4 into 3 and the remaining 2 into 1 becomes 2 factorial. So which gets cancelled with the 2 factorial of the denominator. Therefore, remaining we have divided by 2 whole divided by. In 10 factorial, we'll consider only 10 into 9. Remaining 8 factorial will get cancelled with 10 minus 2 factorial, this part. And we have 2. So 2 into 2 is 4, 3 into 2 is 6, divided by 2 into 5 is 10, 9 into 5, 45. And both the numbers are divisible by 3, right? So 3 into 2 is 6, 3 into 1, 3 into 5. 2 by 15 is the required probability, right? Probability of yielding minimum amount, right? Therefore, so this is nothing but if you pick in 15 ways, if you pick 2 coins in 15 ways, in 2 ways you will get the minimum amount, right? That means in 2 ways you will get minimum amount. In the remaining 13 ways, you will get more than 2 rupees, right? Therefore, so 2 by 15, option B is the right answer. Question number 18. An urn contains 8 blue and 4 green balls. 2 balls are drawn at random. The probability that both balls are of the same color, all balls are considered to be different, right? Is. So here, we'll consider an urn which contains 8 blue balls, right? 8 blue balls and 4 green balls. When 2 balls are drawn at random, we have to draw 2 balls at random. The probability that both balls are of the same color. That means, so either you have to draw 2 blue balls or 2 green balls. 2 blue balls or 2 green balls. In how many ways these 2 cases can be drawn? That means 2 blue balls can be drawn, right? And 2 green balls can be drawn. In how many ways, right? So divided by total number of ways in which 2 balls can be drawn out of 8 plus 4 balls, which is out of 12 balls, right? Therefore, the probability says, the probability is nothing but, right? So the number of ways in which 2 balls of same color, right? 2 balls of same color can be drawn. Same color can be drawn divided by, right, number of ways, or you can mention it as total number of ways in which 2 balls can be drawn, right? 2 balls can be drawn. So these 2 balls can be of same type or cannot be of same type, right? Therefore, we'll consider number of ways in which 2 balls of the same color can be drawn, right? Here are 8 blue balls. We have to draw 2 blue balls out of them, right? Therefore, it is 8C2 ways in which 2 balls can be drawn, right? Plus, out of 4 green balls, we have to draw 2 green balls, right? Therefore, it is 4C2 ways we can draw 2 green balls, right? Divided by total number of ways in which 2 balls can be drawn means, so in total number of balls, in 12 balls, we have to draw 2 balls, right? So we can draw 2 balls in 12C2 ways, right? Therefore, the probability is the ratio of these two, right? Therefore, 8C2, simplify it, it is 8 into 7. Again, we are using NCR is equal to factorial n by factorial r divided by n minus r factorial, right? So, 8 into 7 divided by 2 factorial right? Here, the remaining part, 6 into 5 into 7 into up to 1 will get cancelled with, so n minus r, which is 8 minus 2, which is 6 factorial, right? So directly I'm going to the simplification part. So 4 into 3 divided by 2 whole divided by 12 into 11 divided by 2, since 2 factorial is 2, right? Therefore, so here 2 factorial is 2 into 4 is 8. So it is 28 plus here 2 into 2 is 4. So it is 6 divided by 2 into 6. Therefore 11 into 6 is 66. So 28 plus 6 is 34. Right? By 66. So we can, both the numbers are even numbers. So 17 into 2 is 34 and 33 into 2 is 66. Therefore, the required probability is 17 by 33 is the probability, right? Right? So that means if you draw two balls out of the urn, right? If you draw two balls out of the turn, so out of 33 ways, right? Out of 33 ways, in 17 ways, you will get the two balls of same type, same color, right? So that is the meaning. Therefore, option A is the right answer. Question number 19. A and B alternatively throws a pair of dice. A wins if he throws 6 before B throws 7, and B wins if he throws 7 before A throws 6. What are their respective chances of winning if A throws the dice first? Right? So here, so we'll consider the case of A, person A and B. Right? Alternatively throws a pair of dice. So both are throwing pair of dice, means two dices, right? Two dices they are throwing, each person. And alternatively they are throwing means first A throws the pair of dice, next B throws it, then again A throws, then B throws, and it continues, right? Till n number of times. Here, how many times they are throwing, it is not given, right? So we'll consider n number of times they are throwing alternatively, right? So in this case, so we'll consider case of person A, right? Here he is throwing two dices, right? And he gets sum of 6 in how many ways, that we need to consider, right? Right? So here, ways of throwing two dices. So in how many ways two dices can be thrown? So each dice can be thrown in 6 ways, right? Therefore, it is 6 into 6, right? So ways of throwing two dices is equal to 6 into 6, which is 36 ways. In 36 ways, in how many ways he gets the sum of 6? That means the sum of two top faces should be equal to 6. In how many ways? So we'll consider ways of getting sum 6. Ways of getting a sum 6 is equal to, in how many ways we can get? So if first top face is 1, right? Second top face is 5, you will get sum as 6. 1 plus 5 is 6, right? If first top face is 2, second top face is 4, you will get 6, right? So if both the top faces are 3 and 3, you will get sum as 6. Then top faces are 4 and 2, you will get the same sum. In case of 5 and 1, you will get same sum, right? There are 5 ways of getting a sum 6, right? So out of 36 ways, you will get in 5 ways the sum 6. Therefore, probability of getting 6, of getting sum 6. We all know the formula for probability. So favorable outcomes by total number of outcomes. Here, ways of getting sum 6 is nothing but our favorable outcome. So which is 5 way, right? So totally 5 ways out of 36 ways. Total number of ways of throwing, 36 ways. Therefore, probability of getting sum 6 is 5 by 36, right? So I'll mention this probability of getting sum 6 as PA. Right? PA is equal to 5 by 36. Now we'll consider probability of not getting some 6, right? So we'll consider probability of not getting 6, that is some 6. So I'll mention it as, so probability of a complement or a prime, right? So which is equal to, so 1 minus, here highest probability is always 1, so it cannot be more than 1. So highest probability is 1, therefore we'll consider 1 minus 5 by 36. So 1 minus probability of getting some 6. So which is equal to 36 minus 5 is 31 by 36 is probability of not getting 6, right? So which is P of A prime, right? Now we'll consider, so chances of winning A according to the question. So what are their respective chances of winning A is asked. Therefore, so we'll consider chances of winning A now. Chances of winning person A is equal to, so here at first A throws a pair of dice, right? Therefore it is probability of A, right? Getting some 6, probability of getting some 6. So next, so in the next roll, B throws a pair of dice. Here we are considering the alternative cases because this chance is pertaining to only A, right? Person A. Therefore, we are considering only A cases. We'll consider the third time. So here in first case, A throws pair of dice. In the second case, B throws. We'll consider the third case, right? Where A throws the dice, so probability of getting 6, right, into probability of not getting 6, which is probability of A prime, right, into probability that B doesn't throw the dice. B is not getting 7, some 7, right? Here it is given that A wins if he throws 6 before B throws, right? B doesn't win if A throws. Therefore, so in the third case, right? So B doesn't throw the dice. That means B doesn't win, right? Particularly. Therefore, we'll consider P of B prime, right? P of B prime plus, in the fifth case, again, A has to throw the dice, probability of getting 6 into probability of not getting 6, which is P of A prime, into probability of not getting 7 by B, right? Probability of not getting 7 by B, which is P of B prime, into probability of not getting 6 into probability of not getting 7, and it continues, right? Because in the third time you are taking, therefore again we have to multiply the probability of not getting 6 and not getting 7, right? So before that we'll consider probability of not getting 7 and getting 7s. For that, so we'll consider case of B. Here, ways of throwing. So ways of throwing 2 dice are again 6 into 6, there are 36 ways of throwing 2 dice. So in that, ways of getting some 7. Here B wins if he throws 7, right? Before A throws 6. So ways of getting some 7 is equal to, right? In how many ways we can get some 7? In 7 different, in 6 different ways, right? So they are, if you get 1 at the top face and 6 at the top face of next dice, the sum becomes 7, right? If you get 2 and 5, the sum becomes 7. If you get 3 and 4, the sum becomes 7. If you get 4 and 3, the sum is 7. If you get 5 and 2, sum is 7. Then 6 and 1. In these 6 cases, the sum of the top faces of 2 dice is equal to 7, right? Therefore, there are 6 ways of getting sum 7. Therefore, probability of getting sum 7. Probability of getting sum 7 is equal to, so out of 36 ways, there are 6 ways of getting 7. Therefore, the probability 6 by 36, which is nothing but 1 by 6. I'll mention this as probability of B, right? B getting sum 7, right? Now consider probability of not getting sum 7. Probability of not getting sum 7. So we'll mention it as probability of B complement, right, is equal to 1 minus 1 by 6, which is 5 by 6, right? So the probability of B complement is 5 by 6. Now substitute these values here. So for chances of winning A, here probability of getting 6, P of A is how much? P of A is 5 by 36. 5 by 36 plus again P of A 5 by 36 into P of A prime. So which is 31 by 36 into probability of not getting 7, right? When A gets 6, right? That is P of A. B doesn't get 7, right? So it is P of B prime. Here it is multiplied. So P of B prime is 5 by 6 plus here P of A is 5 by 36 into P of A prime is 31 by 36 into P of B prime is 5 by 6. Again it is multiplied by P of A prime 31 by 36 into 5 by 6 and it continues. Therefore, we have got a progression, right, which has a common ratio, right? Here common ratio, we have got a series or progression. Here the common ratio is how much? 31 by 36 into 5 by 6, right? So if you divide the second term by if you divide first term by second term, right? So you will get, if you divide not first term, second term. So second term by first term, you will get a ratio, right, which is called common ratio. Ratio between two consecutive terms is called ratio. So if it is common, then it is called common ratio, right? Therefore, the given progression or series is a geometric progression. Geometric progression. So how to solve geometric progression or how to find the solution in geometric progression? Therefore, solution is equal to, in case of geometric progression, it is A by 1 minus R, where A is first term, right? So R is the common ratio. Therefore, so what's the solution? Here A is first term, which is 5 by 36 whole divided by 1 minus common ratio 31 by 36 into 5 by 6, right? Therefore, simplify it. So here 5 by 36, take this LCM, which is 6 into 36 to the numerator, then whole divided by 6 into 36 minus 5 into 31. So that you can cancel 36 and 36. 5 into 6 is 30. And in the denominator, we have 6 into 36, which is 216. 216. Sorry. 6 into 36 is 216 minus 5 into 31, which is 155, right? Therefore, we have 30 by 61 as the answer. So, which is nothing but, so their respective chances of winning, right? Probability of winning is, so 30 by 61. Am I right? 30 by 61. Probability of winning A, right? Now consider chances of winning B, right? So chances of winning B or probability of winning B is equal to, here, so after the first throw, after the first roll, right, in the second row, in the second roll, B throws a pair of dice. Therefore, probability of getting sum 7, which is PB, right? We have denoted with PB, right? So PB, in that case, A doesn't get the sum 6. So probability of not getting sum 6, which is P of A complement, plus in the next case, when B throws the dice, it becomes P of B, probability of getting sum 7, into probability of not getting sum 6 by A, into probability of probability of not getting sum 7, again probability of not getting sum 6 into probability of not getting sum 7, and it continues. Therefore, again a geometric progression whose common ratio is equal to, so what's the common ratio if you substitute the values here? So better to substitute the values before taking common ratio. Here probability of B is 1 by 6 into probability of not getting sum 6 is equal to 31 by 36, plus again probability of B is 1 by 6 into probability of not getting sum 6 is 31 by 36. 31 by 36 into probability of not getting 7, which is 5 by 6, right? Into probability of not getting sum 6, 31 by 36, not getting 7, 5 by 6, and it continues. Right? And it continues. Therefore, we have the common ratio as, in this case, we have the common ratio. What's the common ratio here? So again 5 by 6 into 31 by 36 is the common ratio. Right? Whereas the first term is A is 1 by 6 into 31 by 36. Right? Therefore, the solution is, so A by 1 minus R, which is nothing but A is, what's the value of A? 1 by 6 into 31 by 36 whole divided by 1 minus common ratio is 5 by 6 into 31 by 36. So the LCM and denominator of the numerator, so 6 into 36 will get cancelled, right? These two. So 31 by, in the denominator, the first term becomes 6 into 36 minus 5 into 31. Right? As in the previous case. So this part 6 into 36 minus 5 into 31 is 61. So we have 61 in the denominator and in the numerator we have 31. Therefore, the required probability is 31 by 61. So that means chances of winning B. Right? So the question is, what are their respective chances of winning if A throws the dice first? We have taken A throws the dice first. Chances of winning are 30 by 61 and 31 by 61. Option B is the right answer. Right? 30 by 61 and 31 by 61. Question number 20. Two numbers are selected from the set of integers 1 to 25. What is the probability that the product of the numbers will be 48? Here, the probability, right, is related to the product of two numbers. So it should be equal to 48. So how many sets can be formed? A set of two numbers can be formed, right, using the numbers 1 to 25. So probability, I'll write the formula directly. Probability is nothing but number of set of two numbers, whose product is 48. This is the favorable outcome, divided by total number of set of two numbers, right? Total number of set of two numbers out of how many numbers are given? 1 to 25. Out of 25 numbers. Right? Out of 25 numbers, we can form set of some set of two numbers, right? You can form 1 and 2 as one set of two number, 2 and 3, like that. Some set of two numbers can be formed out of 25 numbers. In that, some set of numbers, right? Some set of numbers, each set contains two numbers whose product is equal to 48, right? That gives the probability. So therefore, so we'll consider number of set of two numbers whose product is 48, right? We'll consider numbers from 1 to 25 here. So 1 to 25 we are considering. Therefore, 2 into 24 becomes 48, right? Set of two numbers, 2 and 24. So one set of two numbers. And 48 is divisible by 3. So 3 into 16. 3 and 16 are, so is the another set. Then 4 and 12. This is another set. Then 5 is not divisible by 6 is divisible by 48. So 6 into 8. Right? So 6, 8 is another set. So next comes 8 and 6, which is same as the previous set. Therefore, we can form 4 sets, such sets, right? Therefore, number of set of two numbers whose product is 48 is 4. We can form 4 such sets, such that their product is 48, divided by total number of set of two numbers out of 25 numbers. That means we can form 25C2 number of sets, right? Out of 25 numbers, you have to select two numbers, right? Therefore, 25C2 sets can be formed, right? Therefore, 4 divided by 25C2 is 25 factorial divided by 2 factorial into 25 minus 2 factorial, which is 23 factorial, right? 4 divided by, here in 25 factorial, we'll consider 25 into 24 and remaining 23 into 23 into 22 into so on up to 1 will get cancelled with 23 factorial in the denominator. So we have 2 in the denominator finally. So 2 into 12 is 24. Therefore, we have, so 4 by 25 into 12 is 300. 4 by 300. Still we can simplify, right? So 75 to 4 is 300. Therefore, 1 by 75 is the answer, right? So option B is the right answer. So probability that the product of numbers will be 48 is 1 by 75, right? Therefore, so that means, so out of 75 set of numbers, right? The product of numbers will be 48 is only 1. So option B. Question number 21. A 5-digit number is formed by using the digits 1, 2, 3, 4 and 5 without repetitions. What is the probability that the number is divisible by 4? Right? Here, the required probability, right, that the number is divisible by 4 is equal to, so number of 5 digits numbers which are divisible by 4 divided by total number of 5 digits number, right? Here favorable outcomes are, so number of 5-digit numbers, right? Number of 5-digit numbers which are divisible by 4, right? Which are divisible by 4 is the favorable outcome divided by total outcome is nothing but total number of 5-digit numbers, right? Total number of 5-digit numbers. It is understood that 5-digit numbers which can be formed out of given 5 digits, right? 1, 2, 3, 4, 5, right? So here, how many 5-digit numbers can be formed which are divisible by 4? So if a number is given, so for example, we'll take the given 5-digit, right? Here, 12,345 is not divisible by 4 because the last two numbers, so last two numbers are 4 and 5. So you'll consider 45, right, as the last number. If the last two digits, so together it becomes 45. If it is divisible by 4, then the whole number is divisible by 4. So divisibility rule of 4 says a number is divisible by 4 only if the last two digits are divisible by 4. Together, last two digits form a number. That number should be divisible by 4. Therefore, so ways of forming last two digits out of 1, 2, 3, 4, 5, right? So we'll consider ways of forming last two digits out of 1, 2, 3, 4, 5. So which are divisible by 4, right? Divisible by 4. So you can consider first 3 digits and last 2 digits, right? So these last two digits can be 1 and 2, so that 12 is divisible by 4, or it can be 32, which is divisible by 4, right? Or it can be 24, which is divisible by 4, or it can be 52, which is divisible by 4, right? So these 4 numbers can be formed, which are divisible by 4, right? Right? So in how many ways these 4 numbers can be arranged in last 2 digits? We can write 12, or you can write 32, 24, or 52, right? Therefore, these 4 numbers can be arranged in 4 ways. In 4 ways, these 4 numbers can be arranged, right? Which is nothing but 4C1, right? That means you have to pick any one number out of 4 numbers, right? So 4C1 is nothing but 4 ways, right? So in the remaining 3 numbers, right? So consider the remaining 3 digits. In how many ways these 3 digits can be arranged, right? So ways of arranging these 3 digits is nothing but factorial 3. In factorial 3 ways, these 3 digits can be arranged, right? So that product of factorial 3 and 4, right? Factorial 3 ways into 4 ways. So this gives, right, the number of ways in which the given numbers are arranged such that those numbers are divisible by 4. Right? Therefore, come back to the question here, the probability, right? Number of 5-digit numbers which are divisible by 4 are factorial 3 into 4, right? These numbers, right? So factorial 3 into 4, right? These many numbers are divisible by 4, which are 5-digit numbers, divided by total number of 5-digit numbers are, so out of the given 5 digits, we can form factorial 5 number of 5-digit numbers, right? Factorial 5 number of 5-digit numbers. Therefore, we have, so 3 factorial and 3 factorial will get cancelled. We have 4 by 5 into 4 in the denominator, because the remaining part 3 into 2 into 1 will get cancelled with 3 factorial of the numerator, right? Therefore, 4 and 4 will get cancelled. We have 1 by 5 as the final answer. So the probability that the number is divisible by 4 is 1 by 5, right? So out of 5 5-digit numbers, 1 5-digit number is divisible by 4. The meaning is like that. Therefore, option A is the right answer. Students, if you want to practice such questions on probability, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 22. The odds in favor of A solving a problem are 3 to 4, and the odds against B solving the same problem are 5 to 7. If they both try the problem, the probability that the problem is solved is. Here, students, let the two events, we will consider two events EA and EB. Right? We'll consider two events. So, odds against favor of one A are. So, here odds in favor of A solving a problem are 3 to 4. 3 is to 4. So, we'll consider odds in favor of A. Right? So, we'll consider case of A and B, EA and EB events. So, odds in favor of A. Odds in favor of A are 3 is to 4, right? So the probability that solves a problem, right? Probability that solves the problem PEA is equal to, so in favor of A are 3:4. That means out of 7, right? So in favor of A are 3. Therefore, it is the probability that solves the problem is equal to 3:7 or 3/7, right? So I'll mention that. Probability that solves the problem. Solves the problem is equal to 3/7, right? So probability that A doesn't solve the problem. So if solves the problem is 3/7, if it is the probability that doesn't solve the problem becomes, so we'll mention probability that doesn't solve the problem. Doesn't solve the problem is equal to, we'll mention it as PEA prime. PEA prime, right? So which is equal to 1 minus probability that solves the problem, right? 1 minus 3/7. It is not 3/4. 1 minus 3/7, which is equal to 4/7. 4/7, right? So here we are considering odds in favor of AR, right? In favor of A and not in favor of A, right? Therefore, the respective probabilities. Now consider the odds in favor of B, right? So it is given that odds against B are 5-7, right? Therefore, we'll consider odds in favor of B. Odds we'll consider against B first. Against B are 5:7, 5-7. Therefore, odds in favor of B. In favor of B are, odds in favor of B are, so the reverse ratio, 7:5. So 7 is, the number 7 is in favor, right? Whereas 5 is against, right? So probability that B solves the problem. Probability, if it is in favor of B, then only the B solves the problem. B can solve the problem. Probability that B solves the problem. B solves the problem. So we'll mention it as PEB is equal to, so 7 are in favor of B. Therefore, so out of 12, 7 plus 5 out of 12. So 7 are in favor of B. Therefore, the probability is 7/12. So we'll consider probability that B doesn't solve the problem, right? Probability that B doesn't solve the problem. So we'll mention it as PEB prime is equal to 1 minus 7/12. 1 minus 7/12, which is nothing but 5/12. 5/12 is the probability, right? So now come back to the question. So if they both try the problem, the probability that problem is solved, right? If they both try the problem, we'll mention, if they both try the problem, A and B, right? Probability that problem is solved. So probability that problem is solved. So we'll mention it as PE, right? So if they both try the problem, probability that problem is solved becomes PE. So we'll write PE as 1 minus, none of them solves the problem, right? None of them solves the problem. Because 1 indicates the whole probability of solving, right? So if they try the problem, that the probability that problem is solved becomes 1 minus, none of them solves the problem. So 1 minus, what is the probability that none of them solves the problem? So here 1 minus probability that none of them solves the problem is probability that A doesn't solve the problem, which is PEA prime, into probability that B doesn't solve the problem. So PEB prime. That's why we have taken these two probabilities, that A and B doesn't solve the problem, right? So consider the respective values 4 by 7 and 5 by 12, right? Right? So 1 minus 4 by 7 is probability that A doesn't solve the problem, into 5 by 12 is the probability that B doesn't solve the problem. So we'll get, so 12 into 7, 84. So in the numerator, we have 84 minus 20, which is 64 by 84 is the probability that if both of them, A and B, try the problem, the probability that the problem is solved finally, right? 64 by 84, we can simplify. So since both the numbers are divisible by 4, so 4 into 1, 4 into 6, right? Then 4 into 2, 4 into 1. So 16 by 21 is the probability that the problem is solved. 16 by 21 is the probability, right? Option B is the right answer. Question number 23. 3 groups of children contain 3 girls and 1 boy, 2 girls and 2 boys, and 1 girl and 3 boys. One child is selected at random from each group. What is the chance that the 3 selected consists of 1 girl and 2 boys? Let us understand the question first. So students, here will consider 3 groups. Group 1, group 2, and group 3. Group 3, right? So in which group 1 contains, so how many girls? 3 girls and 1 boy. So there are 4 kids in group 1 and 2 girls and 2 boys in group 2. Together it is 4, and 1 girl and 3 boys in group 3. Together it is 4. So there are 4 kids in each group, right? So if one child is selected at random from each group, so imagine you have selected 1 kid from group 1, 1 from group 2, 1 from group 3, right? So the chance that, the probability that 3 selected children consists of 1 girl and 2 boys, right? Probability that in the selected group of 3 children, so 1 is girl, 2 are boys. What is the probability, right? So for that, we'll consider probability of selecting 1 girl and 1 boy from each group, right? Then only you can go for the final answer, right? So we'll consider the probability of selecting 1 girl and 1 boy from each group. Selecting 1 kid is equal to, so here are 3 girls out of 4 children in group 1. Therefore, it becomes, probability becomes, so number of favorable outcomes divided by total number of outcomes. So you have to keep this formula in your mind, right? Favorable outcomes. So I just will mention here, favorable outcomes divided by total outcomes gives probability, right? Total outcomes gives a probability. Therefore, so probability of selecting 1 girl in group 1 is 3 by 4, right? Into, it is not plus, right? So into, you can select 1 boy also from group 1, right? So probability of selecting 1 boy is 1 by 4 because there is only 1 boy in group 1. And probability of selecting 1 girl from group 2 is 2 by 4. Out of 4, you can select 2, right? So into selecting 1 boy is 2 by 4 in group 2. And also in group 3, probability of selecting a girl is 1 by 4 and a boy is into 3 by 4. Right? Right? So now come to the question. So what is the chance that three selected consists of one girl and two boys, right? So we'll consider the probability that the three selected, we have to consider three kids here, three selected consists of one girl and two boys, one girl and two boys is equal to, so just imagine you have selected one girl from group 1, right? So which is 3 by 4 and the remaining two should be boys, right? So from group 2 you have to select one boy, so that is into 2 by 4 into one boy from group 3, which is 3 by 4, right? Plus, in another case, if you have selected one girl from group 2, so which is 2 by 4 is the probability. So the remaining, from the remaining two groups, you have to select two boys, right? So one from group 1, one boy from group 3, right? So probability of selecting a boy is 1 by 4 into probability of selecting boy from group 3 is 3 by 4. Plus another case is, so you have selected a girl from group 3. So probability is 1 by 4 into the two boys should be from group 1 and group 2. So the probabilities are 1 by 4 and 2 by 4. Right? Now simplify. What is the total probability? Since the LCM is 4 cube, right? So the numerators are same. So 3 into 2 into 3. So 9 into 2, 18 plus 3 into 2, 6 plus 2 into 1. Is this 2 into 1? Particularly 1 by 4 is probability of selecting a girl and 2 by 4 and 1 by 4 are the, yes, which is correct. Therefore, it is 2. Therefore, we have 18 plus 6, which is 24, right? Plus 2, 26 by 4 cube. 4 into 4, 16 into 4, 64. Both the numbers are even numbers. So 13 into 2, 26. Whereas 2 into 3, 2 into 2. So 13 by 32 is the probability, right? That means out of 32, 32 ways of selecting one girl or selecting one kid from each group, the ways of selecting one girl and two boys are 13 ways, right? Therefore, 13 by 32 is the answer, option A. Question number 24. A dice is rolled 3 times and the sum of 3 numbers appearing on the uppermost face is 15. The chance that the first roll was a 4 is. So here students, when a dice is rolled, right? So we'll get a number on the topmost face, right? So if the dice is rolled 3 times, so you'll get 3 different numbers. Say for example, we may get 3 different numbers or you may get same numbers, right? Such that sum of the 3 numbers in 3 different cases, right? Sum of the 3 numbers we have got here on the topmost face, their sum is equal to 15, right? So here the probability that or the chance that the first roll was a 4 is. So probability that the first roll, right, in which the top face is 4 is, right? For that, we'll consider the total number of ways, right, in which the 3 numbers occur, right? So after rolling three times a dice, 3 numbers occur, right, such that their sum is 15. We'll consider the total number of ways, right? So number of ways in which so top face in which the sum of the top faces becomes 15 is equal to, so we'll consider the numbers from 3, right? If first top face is 3 and second top face is 6 and next top face is also 6. So the sum becomes 6 plus 6, 12 plus 3, 15. The sum becomes 15. Therefore, 3, 6 is one of the sets. And we'll just rearrange these, right? 6, 3, 6 is also one of the sets. Then 6, 6, 3 is also one of the sets. Right? Now we'll consider the number from 4. Right? So 4, 6, 5 can be a set. Then 4, 5, 6 can be a set, right? Such that their sum is equal to 15. Then we'll start from 5. 5, 6, 4 can be a set. Then 5, 4, 6 can be a set. Then 5, 5, 5. Right? So the top faces are 5, 5, 5. So all the faces are same. So that the sum becomes 15. And we'll start from 6. 6 got over. Then again from 6 we'll consider 6. Then 6, 4, 5 has got over? No. 6, 4, 5 can be a set and 6, 5, 4 can be a set. Right? So these are the possible sets of top faces, right? Top faces of dice such that their sum is equal to 15, right? Therefore, the number of ways in which the sum of the top faces becomes 15 is equal to 10 ways. 10 ways. In which the first roll was 4 is, right? So number of ways in which first roll was a 4 is equal to, so looking at these sets, in how many sets first roll was 4? In this set and next set, right? So in 2 sets, the first roll was 4. Therefore, the number of ways in which first roll was 4 is equal to 2. Therefore, the chance, come back to the question, the chance that the first roll was 4 is, or the probability, right? Therefore, the probability that the first roll was a 4 is equal to, here the favorable outcome is 2, right? So the number of ways in which first roll was a 4 is 2 by total number of outcomes. So total number of outcomes means number of ways in which the sum of the top faces becomes 15 is 10 ways, right? So out of 10 ways, right, such that their sum is equal to 15, out of 10 ways, in 2 ways, we'll get the first roll as 4, right? Therefore, the probability is 2 by 10 or 1 by 5, right? Therefore, option B is the right answer. Question number 25. An urn contains 6 pink and 6 yellow balls. A person draws 2 balls from the bag. What is the probability that 2 balls are different in color? So students, consider an urn which contains 6 pink and 6 yellow balls. Right? 6 pink and 6 yellow balls. So person has to draw 2 balls out of the bag. Right? So he has to draw 2 balls out of the bag. So the probability that 2 balls are different in color. So he has to draw 2 balls in such a way that both the balls are different in color. Right? That means he has to draw 1 pink and 1 yellow balls. Right? In how many ways 1 pink ball can be drawn? And also in how many ways 1 yellow ball can be drawn? That we need to find. Right? So number of ways in which 1 pink and 1 yellow ball can be drawn, right? The total number of ways divided by the total number of ways in which 2 balls can be drawn out of 6 plus 6 balls, out of 12 balls. That gives the probability. So we'll write the probability formula first, right? Probability that the 2 balls are different in color, right, is equal to, so number of ways in which two balls are different in color, right? Different in color, we'll mention in color, divided by number of ways in which two balls are drawn out of 12 balls, right? So here the numerator is nothing but our favorable outcome. So our favorable outcome is to get two balls which are different in colors, to draw two balls which are different in colors, and in how many ways we need to find, right? In the total number of ways of drawing two balls out of 12 balls. So therefore, so we'll consider the case 1 and case 2 because we have 6 pink balls and 6 yellow balls, right? So out of 6 pink balls, we can draw only one ball, right? We can draw only one ball. So in how many ways one ball can be drawn? In 6C1 ways. So 6C1 means, so this is about combinations, right? In 6C1 ways, the different balls can be, one ball can be drawn, right? That is nothing but in 6 ways, right? Whereas we have to draw only one yellow ball, one ball, right? In how many ways? Again in 6C1 ways, right? That means in 6 ways we can draw one ball out of 6 yellow ball. That means you can draw first ball or second ball or third ball or fourth ball or fifth ball or sixth ball. In 6 ways we can draw one ball, right? It may be pink or yellow, right? So what is the number of ways in which two balls are drawn different in color, right? So which is equal to in 6 into 6 ways we can draw, right? So total number of ways are, 6 into 6. Why it is 6 into 6? So just imagine you have drawn a pink ball, right? So along with that, you have to draw a yellow ball also, right? So out of 6 balls, you have to draw yellow ball also. So just imagine you have drawn first yellow ball. This is one way, right? So with the same first pink ball, you are drawing second yellow ball. This is another set, right? So with third yellow ball, it becomes third set. With fourth yellow ball, it becomes fourth set, right? So there is a 6 combination, right? So here there are 6 combination with pink color. Similarly for the second pink ball also there are 6 combination, right? 6 times 6 combination means 6 into 6. So total ways of drawing two balls with different color are 6 into 6, which is 36 ways. Therefore, so come back to the formula, number of ways in which two balls are different in colors is equal to 36 divided by number of ways in which two balls are drawn out of 12, right? So total ways in which two balls are drawn, right, is equal to, out of 12 we are drawing two balls. It is very simple, 12C2. So apply the formula of NCR, which is factorial n, which is 12 factorial, right? NCR is factorial n divided by r factorial into n minus r factorial. Using this formula, so 12 factorial divided by 2 factorial into 12 minus 2 factorial, right? So in 12 factorial, we'll consider 12 into 11 into 10 factorial, right? The remaining 10 into 9 into so on up to 1 becomes 10 factorial divided by 2 factorial is 2 into 12 minus 2 is 10 factorial. So that we can cancel 10 factorial and 10 factorial. Therefore, 6 into 11 becomes 66, right? So total number of ways in which two balls can be drawn out of 12 balls is equal to 66. Therefore, the probability becomes 36 by 66. right? I think both the numbers are divisible by 6, right? So 6 into 6 is 6 into 11, right? 6 by 11 is the probability, right? Option A is the right answer, right? Question 26. Let A and B be two events such that probability of A. So PA is 0.4, PB is 0.3 and P of A union B is 0.7. Then out of four options, A and B are independent, A and B are exhaustive, A and B are mutually exclusive, and none of these. So which of the options is correct? Here for the given two events, A and B are independent when probability of A intersection B is equal to probability of A into probability of B. When this condition holds good, then we can say A and B are independent, right? So here independent, A and B are independent means whether A occur doesn't change the probability of B. Here, so it depends on whether A occur doesn't change the probability of B or not, right? So here A occurred, the event A occurred, right? If it doesn't change the probability of B, if it doesn't change the probability of B, then we can say A and B are independent, right? It is possible only when probability of A intersection B is equal to product of probability of A and probability of B. And the second option is A and B are exhaustive. So A and B are exhaustive only when probability of A union B is equal to 1. Right? Here exhaustive means either A or B, event A or B, or both the events will definitely occur. Right? Either event A should occur or B occurs, or both A and B, event A and B, right, will definitely occur. Will definitely occur. Then we can say both the events are A and B are exhaustive, right? It is possible only when probability of A union B is equal to 1, right? So next option is A and B are mutually exclusive. So it is possible when probability of A intersection B is equal to 0. Mutually exclusive means so both the events cannot happen at the same time, right? So both event A and B cannot happen at the same time. At the same time. Then we can say A and B events are mutually exclusive, right? So we have to check which of the given options is correct, right? Here we'll check whether the events are independent or not. For that, we'll consider A intersection B, probability of A intersection B. The formula says it is probability of A plus probability of B minus probability of A union B, right? So here probability of A, probability of A is given 0.4, of B it is 0.3, minus A union B is 0.7, right? So here 0.4 plus 0.3 is 0.7, minus 0.7 is equal to 0. Here probability of A intersection B is equal to 0. So here according to the options, here A and B are mutually exclusive, right? Because probability of A intersection B is equal to 0. Right? So events are, they are not independent. So option A is not the answer. They are not exhaustive. No need to go for probability of A union B because the value is already given 0.7. It is not equal to 1. Therefore, A and B events are not exhaustive. Right? So events A and B are mutually exclusive because probability of A intersection B is equal to 0. Hence, option C is the right answer. Question number 27. The probability that in a household LPG will last 60 days or more is 0.8, and that it will last at most 90 days is 0.6. Therefore, the probability that the LPG will last 60 to 90 days is. So, students will consider the probability that LPG will last in different days, right? So here it is given that LPG will last 60 days or more, right? So we'll consider greater than or equal to 60 days. The probability is 0.8. So more than 60 days or equal to 60 days. So in these days, the probability, right? So the probability that the LPG will last is 0.8, right? So therefore, for less than 60 days, the probability that LPG will last in less than 60 days, it becomes 1 minus 0.8, right? Which is equal to 0.2 is the probability. And it is also given that it will last at most 90 days is 0.6. Therefore, probability that LPG will last, so in the, at most means less than or equal to 90 days. In less than or equal to 90 days, the probability that LPG will last is 0.6. Right? Therefore, the question is probability that the LPG will last 60 to 90 days. Right? Therefore, the required probability that LPG will last 60 to 90 days. 60 to 90 days means, so less than or equal to 90 days, in between less than or equal to 90 days, and greater than 60 days. Am I right here? Less than or equal to 90 days, right? Greater than 60 days. So how to find probability that LPG will last between these 2 days, 60 and 90 days? So if you subtract less than 60 days probability, right, from 0 to 60 days, the probability is 0.2, right? And together it is less than 90 days. So consider 90 days, right? So together it is 0.6, right? Therefore, the probability that LPG will last less than or equal to 90 days, which is 0.6, minus 0.2 gives probability between these 2 days, right? 60 and 90 days, right? Therefore, probability that LPG will last 60 to 90 days is equal to, we'll consider, is equal to, so less than or equal to 90 days probability minus less than 60 days probability, which is nothing but 0.6 minus 0.2 is equal to 0.4 is the probability that LPG will last 60 to 90 days. So option A is the right answer. Question number 28. Find the required probability that all the vowels come together if the letters of the word anemia are placed at random. So, if the letters are placed at random, in how many ways all the vowels come together? And simultaneously, we need to arrange the remaining letters also. So, how many vowels are there in the given word anemia? There are 5 vowels, right? So, vowels are in the given word, there are A, E, I, A. These are the 5 vowels in the given word. And total letters are, in the given word, total letters are 7. 7 letters. So here, probability that all the vowels come together. So the required probability is nothing but, right, So ways of arranging, or here the outcomes, total outcomes is nothing but ways of arranging all the vowels which come together, right? This is the question. This is the order here, right? The condition here. So ways of arranging all the vowels which come together divided by total ways of arranging all the letters in the given word, right? So your total outcome is total ways of arranging all the letters, not only vowels, all the letters in the word. This is the probability, right? In the word. Here, ways of arranging all the vowels which come together, right? So for that, we'll consider the given word anemia, in which we'll consider vowels first, right? So A, E, I, A, right? And the remaining letters are N and M, right? These are the remaining letters. So wways of arranging these 5 vowels, right? We'll consider ways of arrangement of these 5 letters are 5 factorial. In 5 factorial ways, we can arrange 5 letters, right? So, whereas the remaining letters, in how many ways we can arrange remaining letters? For that, we need to consider this whole A, as one part, right? And letter N as second part, and M as third part, right? In first part, we have arranged all the vowels in first place, right? And right, N in the second place, M in the third place. Whereas in the second part, we'll take N in the first place. We are arranging the letter N first, then the whole first part, right, a set of vowels. Then comes third part, which is letter M, right? Next, I will arrange second part first, right? Letter N first, then comes letter M, which is third part. 1 minute. Letter M, which is third part, then comes a set of vowels, right? Therefore, in this way, so we'll consider letter M first, then N, and set of vowels. Then letter M first, then set of vowels, then letter N, right? Therefore, in this way, we can arrange set of vowels and the remaining 2 letters in factorial 3 ways. Because here are 3 parts. So 3 parts can be arranged. So if you consider blindly 3 numbers or any 3 letters, right? P, Q, R. These letters can be arranged in factorial 3 ways. Simultaneously, first part, second part, third parts can be arranged in factorial 3 ways, such that all the vowels come together here, right? The whole first part is set of vowels, right? But set of vowels in turn can be arranged in factorial 5 ways. Therefore, product of these factorial 5 and factorial 3 gives ways of arranging all the vowels which come together. Therefore, these ways of arranging all the vowels which come together is factorial 5 into factorial 3 divided by total ways of arranging all the letters in the given word, right? So there are 7 letters in the given word anemia. Therefore, total ways of arranging all the letters is 7 factorial. We can arrange these 7 letters in factorial 7 ways. Therefore, the probability is, I'll take this down, right? Required probability is factorial 5 into factorial 3 by 7 factorial. Right, simplified. Factorial 5 into factorial 3 is 6. 3 into 2 into 1, right? By 7 factorial can be written as 7 into 6 into 5 factorial. So that we can cancel 5 factorial and 5 factorial. 6 and 6. Therefore, 1 by 7 is the probability, right? So probability that all the vowels come together, right, in the given one. So Look at the options. Option C is the right answer. Question 29. Cards are drawn from a pack of 52 cards one by one. The probability that exactly 10 cards will be drawn before the first ace is. So here this probability which we need to find, it depends on the number of ways in which 10 cards can be drawn. Right? Out of 52 cards, and also when the aces are removed from the pack. Right? It depends on these two cases. So we'll write the probability, right, first. So the required probability is equal to, so number of ways in which 10 cards can be drawn out of when aces are removed. So how many aces will be there in a pack? Pack of 52 cards, it contains 4 aces, right? So when 4 aces are removed, so 48 cards will be remaining, right? So out of 48 cards, so in how many ways 10 cards can be removed? That is the required outcome, or it is favorable outcome. Whereas total outcome is, so number of ways in which 10 cards can be removed out of total number of cards, right? Number of ways in which 10 cards can be drawn out of total number of cards, which is 52 cards. Right? Out of total number of cards, we are considering only 48 cards in the favorable outcome, right? So into, this is not the answer here. Into, we need to consider the number of aces also, right? We have 4 number of aces. So in 4 ways we can arrange these, right? We can, that means if you keep on drawing 10 cards, right? These 10 cards, so this set must not include the ace, right? After drawing the 10 cards, we should get the 11th card as the first ace. That's what the question is. Probability that exactly 10 cards will be drawn before the first ace is. What are the probabilities here, right? That we need to consider. So therefore, so here we have already drawn 10 cards. So what is the number of cards remaining here? Out of 52 cards, there are 42 cards, right? Out of 42, there will be 4 aces, right? Therefore, it is multiplied by 4 by 42. So, write the probability here. Number of ways in which 10 cards can be drawn out of 48 cards is 48C10 divided by number of ways in which 10 cards can be drawn out of 52 cards is 52C10 into 4 by 42. Right? Very simplification part here. So 48 factorial by 10 factorial into 48 minus 10 is 38 factorial, right? Here students, we are using the formula NCR, which is equal to factorial n by r factorial into n minus r factorial. Here n is nothing but number of cards we are going to consider, and r is nothing but number of cards. That means we are going to draw, right? Which is 10. So whole divided by 52 factorial divided by 10 factorial into 52 minus 10 is 42 factorial, right? Into 4 by 42, right? So we are going to consider the aces also. Here 10 factorial and 10 factorial part will get cancelled. So in 48 factorial, so 48 factorial means 48 into 47 into so on up to 1, right? So up to 38 we'll write, because that 38 factorial will get cancelled with 38 factorial in the denominator, right? So we'll write 48 into 47 into 46 into 45, right? Into 44, so on up to 39. We are taking up to 39 because the next 38 into so on up to 1 will get cancelled, right? With the 38 factorial in the denominator. No need to write 38 factorial here. So we'll directly take the denominator part. 52 into 51 into 50 into 49 into 48, so on up to 43 we'll consider here also, because 42 onwards that part will get cancelled, right? Therefore here, right, from 48 to 43 we can cancel, right? 48, 47, 46, 45, 44, right? Here in the denominator 48 to 43 will get cancelled into 43, right? We'll start from 42 in the numerator. 42 into 41 into 40 into 39. These four numbers will be remained. So this whole part is multiplied by 4 by 42, right? Now 52 into 51 into 50 into 49 multiplied by 4 by 42. So even we can cancel 42 and 42, right? Now we have, so can cancel, so 10 into 4, 10 into 5 is 15, right? Then 4 into 13 is 52. So 13 into 3 is 39, right? Again, we can take 51 as multiple of 3. So 3 into 17 is 51, right? So now we have 41 into 4 in the numerator and 17 into 5 into 49 in the denominator as the probability, right? Therefore, the required probability is, so 41 into 4 is 164, whereas the denominator is 17 into 5 into 49. So 4165, right? 164 by 4165. So probability that exactly 10 cards will be drawn before the first day is 164 by 4165, right? So option B is the right answer. Question number 30. The probability of obtaining a sum of 6 on rolling 2 unbiased dices is. So we'll consider 2 dices, right? On rolling dices. Probability of obtaining a sum of 6. So for that we need ways of obtaining sum of 6 on rolling 2 unbiased dices. So that means, so if you get 1 as the top face, right, on one dice, so you should get 5 as the top face, so that the sum becomes 6, right? In how many ways these top faces can be obtained such that their sum is 6? And also in how many ways, or in how many ways we can get 2 top faces out of 6 plus 6, 12 faces, right? Therefore, the required probability of obtaining sum of 6 on rolling 2 unbiased dice is ways of obtaining a sum of 6, which is nothing but the favorable outcome, obtaining a sum of 6 divided by total ways of obtaining any number. You can obtain 1 and 1, right? So in how many ways the 2 dices can be rolled, right? Total ways of obtaining 2 faces, right? So here, so this ways of obtaining sum of 6 is nothing but favorable outcome. So that is nothing but what outcome we need here, right? Divided by total outcomes. Right? So in how many ways we can obtain the sum of 6? So for that we'll consider the top face as 1 in first case. So next top face will be 5. This is the one way. And in another way, if top face is 5, we just interchange. So top face of first dice is 5. So top face of another dice will be 1, right? We'll consider 2 as for top face. So top face of another dice will be 4, right? So if 4 as top face, another top face will be 2. We'll consider 3. So another dice top face should be 3. Just interchange, right? So then, so in another method, 4, yes. 4 2 2 4 got over. Then 5 1 1 5. Yes, these methods got over. Therefore, so there are 5 ways of obtaining 2 top faces such that their sum is 6. Right? So favorable outcomes are 5 and total number of ways of obtaining 2 faces. So here obtaining 2 faces means, so if you roll first dice, you may obtain 1 as the top face, 2 as the top face, 3 as the top face, 4 as the top face, right? So in how many ways top face can be obtained? In 6 ways, right? For each top face, 1, for example, 1, you will get 6 different top faces in dice 2. In dice 2, you may get 1 as top face, right? So these combinations are 6 into 6, right? Are you getting my point? So for one face, you have 3 options in another dice, right? So for phase 2, as a top face, you have 6 options, right? For phase 3 also, you have 6 options for that, right? So in this way, 6 into 6 becomes 36. 5 by 36 is the probability of obtaining top faces such that their sum is 6. Sum is 6. Therefore, options here, option B is the right answer. Question number 31. Find the probability of getting a royal red honor from a well-shuffled pack of cards. That means here the favorable outcomes are number of royal red honor cards from a pack of cards, right? Divided by total outcomes are total number of cards in a pack, right? So here we'll consider the required probability of getting a royal red honor card is equal to number of royal red honor cards in a pack divided by total number of cards, right? So how many royal red honor cards will be there in a pack, right? So here the 4 highest cards in each suit are called royal red honor cards, right? So particularly red honor cards. So here they are asking for royal red honor cards. So we have 2 sets of red cards in each set, right? So in that, the 4 highest cards in each suit, right? 4 highest cards in each suit are ace, king, queen, and jack, right? Ace, king, queen, and jack. So in a pack of 52 cards, here the total number of cards are 52, right? In that, 2 suits are of red, right? So in that, in each red suit, there are 4 royal honor cards will be there, right? Ace, king, queen, and jack. Therefore, in 2 suits, we have totally 8, right? Therefore, number of royal red honor cards are 8 divided by total number of cards, which is 52. Therefore, 8 by 52 is the probability. On simplification, since both the numbers are divisible by 4, so 4 into 2 is 8, then 4 into 1, 4 into 3. So 2 by 13 is the probability. Hence, option B is the right answer. Students, if you want to practice such questions on probability, please visit our website at www.examsnet.com. You can also download our app. The link is given in the description box. Question number 32. The probabilities of 3 mutually exclusive events A, B, C are given 2 by 3, 1 by 4, and 1 by 6 respectively. The statement, so the given statement, whether it is true or false, nothing can be said and could be either. So which is the correct answer we need to find. It is given that the given three events are mutually exclusive events. Mutually exclusive events means there will be no common points between these events. That means there will be no intersection of these events. That means, so probability of A union B union C, right? So these three events are independent. That means P of A plus P of B, probability of B, plus probability of C. Sum of these probabilities equal to probability of A union B union C. There is no common point, right? There will be no common points between these events. Therefore, it is sum of three events is equal to union of three events, right? So we'll consider sum of three events here. So PA is probability of A is, so we'll consider PA plus P of B plus probability of C, sum of three events. So which is 2 by 3 plus 1 by 4 plus 1 by 6, right? Since the LCM is 12, the numerator becomes, so 2 into 6, so it is 12, 4 into 3, hence 1 into 3, plus 6 into 2 is 12, hence 1 into 2, right? So 3 into 4 is 12 here in the first part. So it becomes 8. So 13 by 12. So which is greater than 1. 1 point something you will get. So which is greater than 1. So probability of an event cannot be greater than 1. It is always 1 or less than 1. Right? So which is not possible. Not possible. For the given events, for the given values of probabilities, so we cannot say the probabilities of three events are mutually exclusive. We cannot say that because the sum of their probabilities is greater than 1, which is not possible, right? Ideally. Therefore, the given statement is false. Option B is the right answer, right? So the reason is probability of an event cannot be greater than 1. Greater than 1. Whether it is a mutually exclusive event or whether it is an exhaustive event, right? Whichever may be the kind of event, probability cannot be greater than 1. Hence, the given statement is a false statement. Question number 33. A man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. The probability that it is actually a 6 is. So this type of probability is called conditional probability. So we'll consider conditional probability. What actually conditional probability is, right? So here, so we'll denote with probability of A by B. Right? So it is the probability of an event A, for example, event A, right? Probability of event A, which is occurring, given that event B occurs, right? We'll mention that probability of event A occurring, given that event B occurs. Here, probability of event A out by B, A out of B, right? So here, event B occurs. So what is event B in the given question? So here, the event in which man is known to speak truth 3 out of 4 times is event B, which occurs already. Because of that, right, he reports that, right, it is a 6, right? After throwing a die, he reports that it is a 6. That is event A, which is occurring now, right? So because of event B, event A is occurring, right? So therefore, probability of A by B, which is conditional probability, right? So probability of A by B, the formula says probability of A intersection B divided by probability of P. An important equation here. For that, let us consider event A and event B separately. Event A and event B, right? In event A, so what is event A? So man is it? No, this is not event A. Man is known to speak truth out of the truth 3 out of 4 times. Here, this is event B, right? So which occurs? So truth 3 out of 4 times. Out of 4 times, he speaks the truth 3 times, right? This is event B, whereas event A is so reporting the face as 6, face of a dice as 6, right? Which is event A, right? Now let us consider the probability that event A occurs, right? So probability that event A occurs, right? The probability that event A occurs, I'll consider it as PA, right? So he reports that it is a 6, right? So in how many ways a dice can be thrown, right? So in 6 ways. So out of 6 ways, so in one way you can get a 6. Therefore, event A, probability that event A is 1 out of 6, right? So probability that event A does not occur. Event A doesn't occur. So I'll consider it as P of complement of A, right? Or A prime. So which is 5 out of 6. Or you can consider it 1 minus 1 by 6. So which is 1 minus 1 by 6 is 5 out of 6. Since the highest probability is 1, so it is 1 minus probability that event A occurs. So which is nothing but probability that event A doesn't occur, right? Which is P of A complement. So we'll consider event B, right? So probability that event B occurs. Event B occurs. So P of B is equal to, what is event B? So truth 3 out of 4 times, right? So here event B is nothing but telling the truth 3 out of 4 times, right? So 3 by 4 is the probability that event B occurs. So probability that event B doesn't occur. So P of B complement is 1 minus 3 by 4. So which is nothing but 1 by 4, right? Out of 4 times. So he doesn't tell the truth, right? Out of 4 times, he tells the truth 3 times. Therefore, in the remaining 1 time, he doesn't tell the truth, right? Therefore, event B doesn't occur is 1 by 4. Right? So now let us consider the conditional probability given, right? So P of A by B. So this formula. So P of A intersection B by P of B. So for that, we'll consider P of A intersection B. What is P of A intersection B? So A intersection B means events or 2 events which occur at the same time. Events which occur at the same time. Right? So that means, so P of A, what is P of A? Into P of B, right? So P of A is 1 by 6 into P of B. So which occurs, right? So the probability is 3 by 4. Therefore, 1 by 6 into 3 by 4 is nothing but a probability of A intersection B, whereas probability of B is equal to, according to the formula, it is probability of A intersection B plus probability of complement of A intersection complement of B. That means probability that both the events which occur at the same time plus probability that both the events which do not occur at the same time, right? Which do A complement. So we do not occur at the same time. Therefore, so events which occur at the same time, so is equal to 1 by 6 into 3 by 4, which is P of A intersection B, plus P of A prime intersection B prime, or A complement intersection B complement is So 5 by 6 into 1 by 4, right? 5 by 6 into 1 by 4, right? Substituting these two values to get P of A out of B, right? The conditional probability. So it is P of, substitute this in equation 1. P of A intersection B is 1 by 6 into 3 by 4 divided by P of B, which is 1 by 6 into 3 by 4 plus 5 by 6 into 1 by 4, right? So both in the numerator and denominator, we have 6 into 4 as the denominator, right? So numerator of the numerator is 3, whereas in the denominator, we have 6 into 4 as LCM, and in the numerator, we have 3 plus 5. Therefore, 6 into 4 and 6 into 4 will get cancelled. We have 3 by 8 as the probability, right? Right? So the probability that it is actually a 6. That is the conditional probability. That is probability of event A occurring given that event B occurs, right? So it is actually 6. Number of times it is actually 6, right? When the person speaks the truth 3 out of 4 times, right? That is called the conditional probability. So it is completely dependent on the event B, right, which already occurs, right? Therefore, it is called conditional probability. Therefore, so the answer is option A, right? 3 divided by 8, right? Question 34. 3 riflemen take one shot each at the same target. The probability of the first rifleman hitting the target is 0.4. The probability of the second and third rifleman hitting the target are 0.5 and 0.8. Then the probability that exactly 2 of them hit the target is. So what are the probabilities that 2 of them out of 3 men are hitting the target? So for that, we'll consider the probability of hitting the target and not hitting the target. Because in one case, if 2 men are hitting the target, other men will be not hitting the target, right? Therefore, we'll consider the cases, the probability of hitting and probability of not hitting the respective targets, right? Here, for the one rifleman, the probability of hitting the target is 0.4, right? So we'll take probability of first man as PA. Hitting the target is 0.4. Therefore, probability of not hitting will be considered as PA prime will be 1 is the maximum probability, right? So minus probability of hitting gives 0.6. So 0.6 is probability of not hitting the target, right? So for another rifleman, probability of hitting is 0.5, which is given. So we'll consider PB, probability of hitting the target by another man is 0.5. So P probability of not hitting, PB prime or PB dash is 1 minus 0.5, which is 0.5. Right, is the probability of not hitting. For the third person, probability of hitting the target is given as 0.8. Therefore, probability of not hitting PC prime is 1 minus 0.8, which is equal to 0.2, not hitting the target, right? So first 3 values are probabilities of hitting the target. Last 3 values are probabilities of not hitting the targets. Now, the probability that exactly 2 of them hit the target. So there are 3 cases here. So we'll consider probability that exactly 2 of them hit the target. 2 of them hit the target is equal to, so probability of here A and B hitting the target, so that C is not hitting the target. Therefore, probability of A into B into C not hitting the target, C prime, plus in another case, probability of A and C hitting the target, B not hitting the target, plus probability of A not hitting the target, B and C are hitting the target. So A prime B into C, right? So we'll substitute the values, right? Probability of hitting the target by A is 0.4 into by B is 0.5, right? Which is given. So not hitting the target by C is 0.2, right? Plus probability of hitting the target by A is 0.4, by C is 0.8, which is given, by B is not hitting the target, right, is 0.5, plus, so probability of not hitting the target by A is 0.6, probability of hitting the target by B is 0.5, hitting the target by C is 0.8, right? So among three terms, we'll take 0.5 as common. Here 0.5 is common, right? In three terms. So 0.4 into 0.2 is 0.08 plus 0.4 into 0.8 is 0.32 plus 0.6 into 0.8 is 0.48. Therefore, 0.5 into, so sum of these. So 8 plus 2, 10 plus 8, 18. Then 3 plus 1, 4 plus 4, 8. Right? 0.88 into 0.5 is nothing but half, right? So half of 0.88 is 0.44. Right? 0.44 is the probability that exactly two of them hit the target. So option B is the right answer. Question 35. Out of 5 girls and 3 boys, 4 children are to be randomly selected for a quiz contest. What is the probability that all are girls? Here, students, out of 8 children, we have to select 4 children. So, which are girls, right? So, the probability that all are girls will be, the probability formula says it is the number of favorable outcomes by total number of outcomes. Here favorable outcomes are nothing but a number of ways in which 4 girls can be selected. Right? 4 girls can be selected divided by, so number of ways in which 4 children can be selected. They may be girls or boys, or 2 girls or 2 boys, or 1 girl and 3 boys, right? So the total number of ways in which 4 children can be selected. Can be selected. That means out of total number of children, out of 8 children. Here, number of ways in which 4 girls can be selected, out of how many? So that we need to consider. So here are 5 girls given. So we'll consider 5 numbers, right? 5 girls. In how many ways 4 girls can be selected? You can select first 4 girls, or you can select the last 4 girls, 2, 3, 4 and 5, or you can select first girl and third, fourth and fifth, or you can select second, first, fourth and fifth. In how many ways this can be possible? Out of 5 girls, 4 girls should be selected, right? You have to select 4 girls. Therefore, in 5C4 ways, we can select 4 girls, right? Therefore, probability is equal to 5C4, number of ways in which 4 girls can be selected, divided by number of in which 4 children can be selected out of 8 children is 8C4. So, favorable outcomes out of total number of outcomes, right? Therefore, so 5C4 is the number 5 itself. 8C4 is factorial 8 divided by factorial 4 into 8 minus 4 factorial. We are using the formula NCR is equal to factorial n by R factorial into n minus R factorial, right? So now simplify this. So 5 divided by. So in 8 factorial, we'll consider 8 into 7 into 6 into 5 and the remaining part 4 into 3 into 2 into 1, I will consider it as 4 factorial divided by 4 factorial into 8 minus 4 is 4 factorial. So can cancel 4 factorial and 4 factorial. Even we can cancel 5 and 5 here, right? So 1 by 8 into 7 into 6 by 4 factorial is 4 into 3 into 2 into 1, right? So 3 into 2 is 6, will get cancelled with the 6 here. So 4 into 2 is 8. So we have 7 into 2, which is 1 by 14 is the probability of selecting all four girls out of 5 girls, right? Therefore, so 1 by 14 is the answer, right? Option A. Question 36. Probability of happening of at least one of the events is 0.6 and their simultaneous happening is 0.2. Then the value of probability of happening A plus probability of happening B is. So here are two events A and B, right? We'll consider two events A and B, right? These are the events. Probability of happening at least one of the events. Happening one of the events is nothing but probability of A union B, right? At least one of the events is happening. So that means A union B is 0.6. That means events happening at least once, right? So event happening at least once is called, so it is nothing but probability of happening or probability of events A union B, right? Which is 0.6 and their simultaneous happening is 0.2. So simultaneous happening means probability of A intersection B, which is 0.2, right? A intersection B means, so two events happening simultaneously at a time, right? Two events at a time is nothing but A intersection B. Then the value of P of A plus P of B. We know the formula of P of A union B is equal to, so probability of A plus probability of event B minus probability of A intersection B, right? A union B value, probability value is 0.6 is equal to P of A plus P of B minus probability of A intersection B is 0.2. Here we need the sum of P of A and P of B, right? P of A plus P of B is equal to 0.6 plus 0.2, which is 0.8. Therefore, option A is the right answer, right? Question number 37. A bag contains 3 red, 4 white and 5 blue balls. All balls are different. 2 balls are drawn at random. The probability that they are of different colors is. So here we'll consider the probability formula. Probability is equal to, so number of favorable outcomes, right? So favorable outcomes divided by total number of outcomes, right? Total outcomes. Here in this case, favorable outcomes are the total ways of getting 2 balls out of total number of balls, right? So there are 3 plus 4 plus 5 balls. So 7 plus 5 is 12 balls, right? So out of 12 balls, in how many ways 2 balls can be drawn, which is nothing but total outcomes. In that, favorable outcomes are nothing but, so out of so many balls, right? In how many ways we can draw two balls of same color, right? That means favorable number of cases are total number of ways of drawing 2 balls minus ways of drawing balls of same color, right? Minus balls drawn from the same color. So we'll consider favorable outcomes first, right? So here, so according to the question, favorable outcomes are nothing but, so ways of drawing different colors. According to the question, it is different colors So the probability that they are of different colors, right? So out of ways of drawing, it is understood that drawing two balls, right? Two balls out of total 12 balls, right? Here in the numerator, so we have, so in place of favorable outcomes, ways of drawing two balls, right? Two balls of different colors divided by ways of drawing two balls out of total 12 balls, right? So how to find favorable outcomes, right? So ways of drawing two balls of different colors, two balls of different colors is equal to, so here out of total ways of drawing two balls, right? So we have how many ways of drawing two balls out of total balls? So we have 12 C2 ways, right? Therefore, so ways of, right, total ways of drawing two balls minus ways of drawing two balls from same color, right? Ways of drawing two balls of same color. So this difference, total ways of drawing two balls minus ways of drawing two balls of same color gives ways of drawing two balls of different colors. So how many ways are there of drawing two balls out of total number of balls? So here there are 12 balls, right? Total number of balls. In that we need to select two balls. Therefore 12 C2 ways are there of drawing two balls minus ways of drawing two balls of same color, right? Two balls of same color, since there are three types of balls, red, white and blue balls, right? So here, since we are drawing same color balls, right? So when you consider red balls, three red balls, so out of three, we need to draw two balls of same color. Therefore, so both the two balls should be of red. Here in three C2 ways we can draw red balls, plus if you want to draw white balls, so here are how many white balls? 4 white balls, right? So in 4C2 ways, we can draw white balls, right? 2 white balls. Plus in 5C2 ways, we can draw 2 blue balls, right? Therefore, total ways of drawing two balls of same color are 3C2 plus 4C2 plus 5C2, right? Therefore, so simplify it. 12C2 is factorial 12 by 2 factorial into 12 minus 2 factorial, which is 10 factorial, minus 3C2 is nothing but 3 itself, plus 4C2 is factorial 4 by 2 factorial into 2 factorial. Since we are using the formula NCR is equal to factorial n by r factorial into n minus r factorial, right? So here at last it is 5C2, it is 5 factorial by 2 factorial into 3 factorial, right? Just we are simplifying here. So here in 12 factorial and 10 factorial, we can cancel 10 factorial. So we have 12 into 11 in the numerator and 2 factorial is 2, right? So in the next part, so it is 3 plus. In 4 factorial and 2 factorial, we can cancel 2 factorial. So we have 4 into 3 by 2 plus in 5 factorial and 3 factorial, we can cancel 3 factorial. So we have 5 into 4 and in the denominator, we'll have 2. So on simplification, 2 into 6 is 12. So we have 66 minus, so this part, next part becomes 2 into 2 and 2 into 2. So we have 3 plus 6 plus 10. So we have 66 minus 16 plus 3 is 19. Therefore we have 47, right? So it is 47 ways of drawing two balls of different colors. Two balls of different colors, right? What is asked in the question? Probability that they are of different colors. Therefore, required probability is probability is equal to favorable outcomes, ways of drawing two balls of different colors. So there are 47 ways of drawing two balls of different colors divided by ways of drawing two balls out of total 12 balls. So how many ways are there? 12 C2 ways are there, right? Of drawing two balls. So what is 12 C2? It is nothing but 66, right? So out of 66 ways, right? So in 47 ways, we can draw two balls of different colors. Different colors. Therefore, the probability is 47 by 66. So option A is the right answer. Question number 38. From 80 cards numbered 1 to 80, two cards are selected randomly. The probability that both the cards have the numbers divisible by 4 is given by. So out of 80 cards, when two cards are selected randomly, in how many ways two cards can be selected? Right? That gives the total outcome. In that, the two cards which are divisible by 4 is given by. So in how many ways two cards can be drawn such that so they are divisible by 4. Those cards are divisible by 4. That gives the favorable outcome. Right? For that, let us consider the numbers from 1 to 80 which are divisible by 4. Right? So numbers from 1 to 80, so which are divisible by 4. 4 are. So 4 is divisible by 4, then 8, then 12. So all multiples of 4, right? So 4 into 10 is 40, 4 into 20 is 80. Therefore, there are 20 numbers from 1 to 80 which are divisible by 4, right? Therefore, there are 20 numbers, right? In that, we have to select two numbers. In how many ways two numbers can be selected out of 20 numbers, right? That gives the favorable outcome. Here, favorable outcome is nothing but number of ways in which two numbers can be drawn out of 20 numbers, right? So it is nothing but 20 C2, right? Simplify it, which is factorial 20 divided by 2 factorial into 20 minus 2 factorial. And the total outcome is, here the total number of outcomes is equal to, so the number of ways in which two numbers can be drawn out of total 80 numbers, 1 to 80, right? So number of ways in which two numbers can be drawn. Two numbers can be drawn out of 80 numbers. 80 numbers, which is nothing but 80C2. So it is factorial 80 divided by 2 factorial into 80 minus 2 factorial. So the required probability that both the cards have the numbers divisible by 4 is given by. Right? So required probability is so number of favorable outcomes divided by total number of outcomes by the formula it is. So it is factorial 20 divided by 2 factorial into 18 factorial. 20 minus 2 is 18 factorial whole divided by factorial 80 divided by 2 factorial into 78 factorial. 80 minus 2 it is 78 factorial. Therefore, factorial 2 will get cancelled here. So in factorial 20, I'll take 20 into 19. So the remaining terms, I'll take it as 18 factorial. 18 into 1, right? So divided by 18 factorial so that we can cancel 18 factorial and 18 factorial. And in the denominator, I'll take 80 into 79, right? In 18 factorial, I'll take 80 into 79. into 78 factorial, right? The remaining terms I will take it as 78 factorial, and in the denominator we have 178 factorial, so that we can cancel. Therefore, we have 20 into 19 by 80 into 79. So 20 into 4 is 80, right? Therefore, we have 19 by 4 into 79. Therefore, it is 19 by 4 into 79 is, so 9 into 4, 36. So 28 plus 3, 31. 19 by 316 is the required probability, right? So probability that both the cards have the numbers divisible by 4 is 19 by 316, option B. Question 39. In a box containing 100 bulbs, 10 are defective. The probability that out of a sample of 5 bulbs, none is defective is. So out of 100 bulbs, 10 are defective, right? So non-defective bulbs are 90, right? In that, so we need to select 5 bulbs, right? So you cannot select 5 bulbs randomly here. So the probability that out of sample of 5 bulbs, none is defective is the required probability is equal to, so ways of selecting 5 bulbs out of non-defective bulbs, right? Divided by ways of selecting 5 bulbs out of total number of bulbs, right? So ways of selecting 5 bulbs out of non-defective bulbs divided by, so total ways of selecting 5 bulbs out of 100 bulbs, right? Ways of selecting 5 bulbs out of total bulbs, which is nothing but, here total bulbs are 100, right? Total bulbs are 100. In that, defective bulbs are 10. So non-defective bulbs are 90, right? Therefore, out of 90 bulbs, we need to select 5 bulbs. In how many ways 5 bulbs can be selected? In a 90C5 ways, 5 bulbs can be selected. Therefore, our favorable outcome is nothing but 90C5 ways of selecting 5 bulbs out of non-defective bulbs, divided by ways of selecting 5 bulbs out of total bulbs, which is the total outcome here. So out of 100 bulbs, we need to select 5 bulbs. So the ways are 100C5 ways. In 100C5 ways, we can select 5 bulbs, right? They may be defective or non-defective or both, right? So 90C5 by 100C5. So you can simplify it, but in the given options, 90C5 by 100C5 is directly given, right? Therefore, option C is the right answer. Question number 40. A box contains 6 blue and 8 black pens. A pen is selected at random without looking from the box with replacement. Now again a pen is drawn from the box. What is the probability that the first pen is black and the second pen is blue? Right, here we are going to draw 2 pens out of the box, right? So first pen, and again a pen is drawn from the box, 2 pens. So probability that the first pen is black and second pen is blue, you need to find. So we'll consider probability of getting a black pen first, then blue pen, right? So we'll consider probability is equal to probability of getting black pen is equal to, we are using the formula, probability is, so favorable outcomes by total number of outcomes. We all know the formula, right? Here the favorable outcome is, so total number of black pens. So there are 8 black pens, right? So favorable outcome is 8 out of how many total pens? 8 plus 6 pens. Therefore, it is 8 by 14, right? So 2 into 4, 2 into 7. So 4 by 7 is the probability of getting black pen, right? Out of 14, you can get 8 black pens. That's the probability, right? So then probability of getting blue pen. Probability of getting blue pen is equal to, there are 6 blue pens, right? So out of 14 pens. So it is 3 by 7 is the probability, right? 3 by 7 is the probability. That means, so 40 out of 14 pens, you can get 6 blue pens. Hence the probability, right? Therefore, so the question is the probability that the first pen is black and the second pen is blue. That means the total probability is the product of these two, right? So required probability is equal to of getting black pen is 4 by 7 and of getting blue pen is 3 by 7, right? Therefore, it is 12 by 49. Right? So these 8 and 14 are ways of selecting black pens, right? So whereas in the second part, 6 by 14, this is ways of selecting blue pen. For example, if you consider 6 blue pens, 1, 2, 3, 4, 5, 6. In how many ways these 6 pens can be selected? So one blue pen can be selected out of 6 pens. So in 6 ways you can select. You can select first blue pen or second, third, fourth, fifth or sixth. In 6 ways this can be selected. Therefore, this 6 way is outcome or favorable outcome. Right? So it is favorable outcome. Right? Number of ways in which that particular color pen can be drawn. One pen can be drawn in how many ways? In 6 ways. Right? Similarly for black pen. Since there are 8 black pens, in how many ways one black pen can be drawn? In 8 ways. Right? These 2 ways are favorable outcome. So which we are expecting that, right? So out of total number of outcomes. So out of the total number of outcome means in how many ways one pen can be selected out of total pens. Total pens are 14. So in how many ways one pen can be selected? So in 14 ways, right? 14 ways. Therefore, the probability is 8 by 14 and how much? 8 by 14 and 6 by 14 in 2 cases. Therefore, probability of getting these 2 pens is the product of 2 probabilities. Hence, 12 by 49 is the required probability. Look at the options here. Option A is the right answer. With this, I am completing this paper, students. If you want to practice such questions on probability, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you all the best for your future exams.